Hi, everybody. Thank you for joining. Can you hear me well? Thank you for joining this session. My name is Carol Pereira. I'm a product marketing manager with the Tanzu team to bring you guys the best container management solutions we have out there within our Tanzu portfolio. And we're here today to talk about the top 5 tools customers want when managing multi-cluster Kubernetes. Do you guys have multiple clusters or 1, 2 clusters above 10, more than 10, more than 20? We do ask customers every year, let's see. So, and you're wondering, you may be wondering, how do we know which 5 tools they want, right? What are the top tools? Because we ask literally. So this is a QR code for our State of Kubernetes survey that we run every year. And we ask customers a lot of questions, which Kubernetes distributions they're running, where they're running, if they're doing, public cloud, multi-cloud, all those sorts of questions, including the challenges they have when managing multi-cluster Kubernetes environments, and also the top 5 tools that would help them managing those clusters. So before we dive into the tools themselves, the challenges that they tell us they face those are the top 3 trending up from past years. So you see internal experience and expertise. Security is always at the top 3, so very top of mind for our customers. And also difficulty to manage cluster lifecycle and upgrades. So those are again, it's trending up. You can see from the past year. So the dark blue at the top are the results for 2023. So we know that expertise is a very big challenge, but Tanzu solutions allow you to do a lot of the management pieces of Kubernetes with no YAML exposure or no need for YAML. We have a user experience that allows you to do a lot of things if you don't have that experience. But for teams that do, again, we have multiple options on how to interact with our Kubernetes operations solutions. On the security piece, again, we try to make security boring with a policy engine that has a lot of out-of-box policies, a lot of ways to apply it to clusters, groups of clusters, individual clusters at the org level, so various levels of strictness for policies. And in the cluster lifecycle management piece, again, we strive to bring you a truly multi-cloud solution. So we've been adding, since we released Tanzu Mission Control, for example, which is our Kubernetes management offering that we're going to cover here in more detail today. It started with Tanzu Kubernetes Grid, ability to do cluster lifecycle management, and then we added Amazon EKS clusters last year, and we just announced Azure AKS clusters too. So you can do all of the cluster lifecycle management, create, update, upgrade, delete clusters directly through Tanzu Mission Control, for example. And if security is definitely top of mind for you, if you're in the regulated industry, financial services, healthcare, we also recently launched a self-managed deployment option for that Kubernetes management piece. So we initially only had we had it as a SaaS offering only, but of course our regulated customers and our partners that are building sovereign clouds came to us and were asking for that self-managed deployment for air-gap environments, and now we offer that too, if you're interested. Now the top tools. And you see here I have 6, not 5. So you paid for 5, but you get 6. And what happened is that we had a tie in the 4th place there, so I decided to throw another one in there. So this is the actual ranking, of the top most important tools that our customers tell us all the way down. So you see, again, data security and protection is number 1, top of mind. They tell us platform monitoring and alerting is very important too. Software and package management, how do we make things more easy? Infrastructure as a code integration for those out there that do use, Terraform, that have that knowledge within your teams. They want to interact with Tanzu solutions through Terraform providers too. Cluster lifecycle management, again, top of mind, and policy management and compliance, guardrail enforcement, which is actually the main use case we see for mission control specifically, right? So how do we solve all of those problems, or how do we provide all of those tools for our customers? And the answer is Tanzu for Kubernetes Operations, which is a solution that includes the Kubernetes management piece, brought to you by Mission Control at the top there, It also has observability, service mesh, and you might have seen on the keynotes and the solution keynotes that we're combining that Kubernetes operations piece inside what we now call Tanzu Application Platform. So initially we had Tanzu Application Platform as a solution, Tanzu for Kubernetes operations as a separate solution. They're now being combined, and they go, from end to end, including a developer portal, supply chain, software supply chain, under the application platform, and it goes all the way through operations with those capabilities. Observability is one that may be included with the Tanzu intelligence services that we're also announcing. So you see more of that, but for today, let's deep dive on Tanzu Mission Control. So again, it offers policy management, cluster lifecycle management, data protection, a bunch of things that our customers tell us every year that they value, and they want to make it easier. So going back to the tools, their top one, right, on that list of 6 was data protection. And again, we have data protection provided by Valero, which is an open source project. It comes with Tanzu Mission Control, so you can do cluster backup of entire clusters, partial clusters. You can use labels. We recently announced CSI snapshot for persistent volume. So if you have stateful applications running, we have CSI in addition to file system backup. So a lot of options, a lot of flexibility. And we provide support for multiple target locations, Amazon S3, Azure Blob Storage. So very flexible and low management overhead because Valero is included with the solution, right? You don't have to apply that on multiple environments or multiple clusters. Top 2, platform monitoring and alerting. And today with Tanzu Mission Control, we do have an integration with ARIA Observability, which was formerly known as Tanzu Observability or Wavefront. You can integrate that through TMC, and it gives you that easy, click to their dashboard from TMC, and you can customize dashboards and, again, look at your cluster's performance. We also have events and logs inside Tanzu Mission Control. You can export those logs to your preferred logging tool. So a lot of options and flexibility on monitoring to inside the tool. Top 3, software package management. And again, we want to help teams deploy those packages to their clusters more easily. So we have integration with the Bitnami catalog of apps, Tanzu package repository too. So it makes it just easier to, again, deploy the packages that you need on your individual cluster or cluster groups. Infrastructure as code integration. So we do have a Tanzu Mission Control Terraform provider that allows you to attach clusters, apply policies, apply service mesh too. So it's very flexible, and we have that option for, again, those teams that want to leverage that knowledge and interact with those tools. And this is for A. Remember, we had a tie. 42% one, infrastructure as code. Same 42% one, cluster lifecycle management. So again, we just announced support for cluster lifecycle management of Azure AKS clusters. Gives you the ability to provision. You connect your either Amazon account or Azure account, and you can provision, create, update, upgrade, delete those clusters directly through Tanzu Mission Control. And outside of the cluster lifecycle management piece, you can also attach any cluster. So the attach, you don't have LCM capabilities, but you can do everything else. So data protection, automation through GitOps, which we also have. You can connect your Git repository to Tanzu Mission Control and apply packages at scale to multiple clusters. So you have all of that, policies through the UI, all of that to your attached clusters too. And you can attach any CNCF conformant, Cloud Native Computing Foundation conformant cluster, OpenShift, Rancher, everything, all your Kubernetes state. And then that's the top 5. The last one I added in there, policy management and guardrail enforcement. So you see here a view of our policy area inside Tanzu Mission Control, and you see there's security, image registry, network, quota, custom, a lot of different policies that you can apply, again, at different levels, groups of clusters, individual clusters. what we call workspaces, which are groups of namespaces. So we have those constructs of cluster groups and workspaces. And we recently also launched mutation policies a few months back, which basically mutates or updates a request based off of what the platform engineering team, you know, included in the platform. So even if a developer submits a request that is different, that is going to get a validation error and not run, the platform will update that request to whatever the platform team wants and will run it accordingly. So why Tanzu Mission Control? Because you can take control of your environment, so your distributed clusters, you can plug it out into the centralized management. You improve efficiency with a lot of templates, and you increase security also with that centralized policy management, data protection capabilities. And if you are interested about security, go check the session. It is today at 10 a.m. So they're going to cover policies, data protection, and also going to cover resiliency with service mesh. So it's a combination of mission control and service mesh on that session, if you're interested. And here are more resources for you. So with that QR code, you get to our Tanzu for Kubernetes operations page. And then if you go and click into the capability of Kubernetes management, I think you get multi-cloud Kubernetes management, you get to the mission control page, which will give you that deeper dive on the key capabilities, some customer success stories, use cases. And over there is our Pathfinder, so you can test drive Tanzu for Kubernetes operations today with that QR code. So with that, thank you. If you have any questions, I'll be hanging around, but thank you for joining my session. Make sure to check out our expo with a lot of demos on Tanzu for Kubernetes operations.
All right. Good morning, everyone. Hope everyone enjoyed the festivities last night and not too hungover here. Thank you for joining my session on mastering multi-cloud networking, unleashing the power of cloud connectivity. So working? Oh. So just a brief look at the agenda. We'll start out with a brief introduction. I'll define what multi-cloud is from a VMware cloud perspective. Talk about multi-cloud networking, some of the challenges and common design patterns you can leverage to unleash multi-cloud networking. Just a brief intro about myself. My name is Justin Brandon. I'm a multi-cloud solutions architect at the Worldwide Multi-Cloud Architecture Group. I've been at VMware for about 2 years now, helping one of our largest GSI partners implement their go-to-market multi-cloud strategy. I have over 12 years experience in the IT industry, focusing on cloud networking design and implementation around VMware clouds. In addition to that, I also focus on Tanzu portfolio from multi-cloud perspective. I live in Southern California with my wife and my dog, Luna. So just to level set, define, multi-cloud, we can all agree multi-cloud is accelerating. Not only is it accelerating on the infrastructure space, but also on every aspect of the IT lifecycle area, including applications. Organizations are looking to modernize traditional applications to a more cloud-native architecture. In addition to that, they're looking to management and operations in a consolidated way across these various cloud platforms. And cloud services are being consumed for machine learning and data models that need to be leveraged across different cloud providers. So all these are pushing more organizations to a multi-cloud environments and adding more complexity day by day. And again, just from a high-level view, so what exactly does multi-cloud mean? So typically we see from our experience with customers on the right, you have your core enterprise applications that exist in a private cloud. Then you have some that exist in AWS, of course, your customer-facing applications. You might have some cloud-based applications in Azure, some other stuff in Equinox. So everything's spread across these different cloud environments. And typically what we see is customers not operating at a very cloud-smart approach. They're looking to sprawl into these clouds as needed and not looking at it in a very cloud-smart strategic approach. So at VMware, we like to say, interoperability is key. Like having that same model and same UI across the different cloud environments enables a truly seamless multi-cloud integration, enabling more agility and more resiliency across the multi-cloud. So now that we kind of defined, what multi-cloud is from an infrastructure piece, let's talk about how can we enable, what exactly is multi-cloud networking from a VMware cloud perspective, and what does it mean? So first, starting out, what is multi-cloud networking? You can see on the left-hand side, we have traditional enterprise networking stack that we're all kind of used to. Typically, those are configured via CLI or GUI typically, or API tools, depending on how you want to push out the configuration. And you compare that to cloud networking, you're looking at limited options for configuration. Typically, stuff is done via the GUI. They have some APIs particularly, and then some CLI options as well. And then enterprise as well. There's an array of options for enabling networking services, whether it's virtual, physical, and it could be a combination of many of those together. When you compare that to cloud networking, everything is virtualized essentially. So you have limited options on that aspect. In addition to that, there's routing protocols. There's more robust routing protocols compared to on-prem environments. There's limited options in the cloud networking. So with all that being said, it's hard to translate your infrastructure on-prem to the cloud. It's rarely one for one. You can't translate all the services, and organizations rarely can do that. So this kind of summarizes what I say multi-cloud networking is. I give credit to another architect I work with named Matt Elliott, who kind of created this. Multi-cloud networking is kind of like Voltron. You're connecting all these services together to enable interoperability across the clouds in an efficient way. So the ability to connect AWS, Google Cloud, Azure, Oracle, to consume the services as you see fit is a true multi-cloud network, I would say. And it's kind of like Voltron. So now we're going to kind of look at some of the actual challenges with multi-cloud networking. So, I mean, multi-cloud networking is hard. I mean, enabling communication across the different cloud providers is not easy. It's very challenging. So what are some of the challenges? Assorted networking infrastructure. So the cloud providers have various networking architectures and topologies that they leverage, making it very challenging to implement standardized architecture across the cloud providers. Vendor lock-in. You know that every cloud provider has different services and different options that you can leverage, making it very challenging to select one type of solution. Security concerns. The cloud providers have different options for securing the workloads in many different ways, whether it's security groups in one cloud provider, other ones have different ways of configuring it, so that's a challenge in itself. How do you move workloads across from different cloud providers while having seamless security posture on all the workloads? Big challenge. As far as network latency, certain cloud providers have regions available and other regions they don't. Some services are available, others are not. So how do you accomplish, that, given that the region limitations that they have? And then, of course, multi-cloud networking, the routing is complex. I mean, enabling communication across these clouds, keeping track of all the actual route tables is a very complex task and very hard. It's challenging. Lack of unified management. Obviously, VMware can help in some of these aspects with the ARIA suite that comes to mind, helping you unify the actual environments and having that visibility into your network infrastructure is key. But still, it is a challenge. Multi-cloud networking is hard, no doubt. Inconsistent services. Some cloud providers have an array of networking options. Some have more robust throughput and bandwidth options, others don't. So that in itself makes it difficult. And then skill set. Skill sets vary from cloud to cloud. Everyone has their favorite cloud they like using. Some like Google, a lot of networking people here are sure you like Google, others don't. So that in itself is a challenge. How do you design your multi-cloud network to accomplish what your organization wants, given that all these hard challenges are in place? So, given that, I outlined how hard it is to implement multi-cloud, so why would you go about doing it? Why would you enable multi-cloud networking for your organization? What's the benefit? And this kind of summarizes it. So why multi-cloud networking? You can see on the top there, we have, you have a full mesh communication across your various cloud environments. And so what does that unlock? So starting from the left, from a VMware perspective, the interoperability and communication across the clouds enables your modern application platform. Having the ability to deploy Tanzu Kubernetes Grid workloads to various cloud environments and having the connectivity to consume those services on what cloud you want to is very powerful. And it reduces costs and increases flexibility, having the ability to leverage what cloud you want. In addition to that, all the VMware clouds are deployed with our software-defined networking stack, NSXT, allowing you to seamlessly migrate your security policies across various cloud providers as you see fit, and enabling more agile and secure environment, so alleviating that security pain point that I pointed out in the earlier slide. Obviously, you have faster deployment of networks. NSX is our software-defined networking stack. All the VMware clouds come with that out of the box, de facto. And you can enable software-defined networking options with that via the API or just standing up layer 2 segments on demand as you see fit and extending those into the various cloud endpoints as you need it. So you have a highly scalable, reliable network once you unleash the multi-cloud connectivity. And then access from anywhere. Obviously, you have this full mesh connectivity to various cloud provider endpoints, allowing you to access services where you see fit and where your organization works best for the users. Okay, so now I kind of sold you on multi-cloud networking, hopefully, and so you want to go forth and what are the options to enable a multi-cloud network? So at a high level, a very basic level, I mean, you want to create connectivity to your a multi-cloud. You can just stand up a simple IPsec VPN. Okay, wow. So with that said, it's just over the internet. You have just standard IPsec VPN. Some of the cons are secure, obviously. If organizations need security is a key, but there is a performance hit. Obviously, you're encrypting over that tunnel. The next option is Layer 2 VPN. Layer 2 VPN is a great option for migrations. You want to maintain the IP mobility across these migrations. You can leverage extension of Layer 2 VPN, but I will say be cautious about that. Layer 2 VPNs are a temporary thing, I say, for migrations. I would bring it down once you're done. And again, IP mobility is the main use case for this. And but there is some performance hit. NSX, HCX are the products that we offer that can help you accomplish this. Oh, okay. Yeah, I was confused. All right. All right. Awesome. So I got more time. All right. So we also have software-defined networking. I'm sorry, SD-WAN. I apologize. SD-WAN, of course. So SD-WAN, some of the things you have is, obviously it's flexible, cost savings. You're using the internet to create this mesh to these different cloud environments. So very cost effective in that aspect. The only challenge with that is there's a potential for vendor lock-in because typically the SD-WAN appliances don't interoperate with each other. For example, VeloCloud or whatever option you're using, just know that there is some kind of vendor lock-in there potentially. Another option for multi-cloud networking is just a leased dedicated line via the cloud providers. Each one has their own style and terminology for it. Interconnect, direct connect, those are the options. Obviously, this is high bandwidth, low latency connection directly into the cloud. I mean, if you wanted to, you can purchase these and connect all your different cloud connectivity options. Some of the problems with this is obviously it's expensive for clients that have budget constraints and costs. It is expensive, obviously. And you get a dedicated circuit, and it requires an edge device that you can terminate to. Some of the ones we offer, obviously, you use NSX, you can terminate there. And the one I want to focus on that we leverage in our multi-cloud environment is a newer option. There's a lot of as a service acronyms out there, and of course, there's one for network. So networking as a service. So this is what we use for our internal cloud environment, and you can think of the providers such as Megaport or Equinix that provide connectivity to the cloud providers. You just need to have a cross connect into their actual infrastructure, and then they have a connectivity into cloud providers. The benefit with this is high bandwidth, low latency connection, easy manageability, configuration via the Megaport GUI, in this case is what we use to add connectivity into the cloud providers. It is expensive, is the only challenge for that one. It is the cost and then the availability. You have to have a co-location where your infrastructure resides so you can connect into their actual services. So that's that. And I want to kind of show a nice reference architecture that one of our teammates made. This kind of walks you through, and I'll share a link at the end on how you guys can access this and build out your own multi-cloud network. So this is what we have in our internal lab environment. We call it the multi-cloud universe internally, and it has a full mesh connectivity to our on-prem environment. We have access to AVS, GCVE, Oracle, and Azure. I'm sorry, VMC. So we have full connectivity. We're leveraging all the hosted connections. So we're leveraging Direct Connect, Interconnect on Google, and we have full, like I said, full mesh established across these environments, enabling full workload mobility. So we can have one application in one environment. We can easily move it to Google, consume those services, move it to another. So it's very powerful. So. Okay, so one of the biggest use cases for enabling multi-cloud networking, like I mentioned, is workload mobility, the option to move workloads as you see fit. So HCX is not only a migration tool, it also is a full mesh service that allows you to have connectivity across your different cloud environments. And the demo I'm going to show is showing our HCX SaaS offering called HCX Plus. And I'm going to walk you through a migration of a workload from our Paris data center into our Palo Alto data center leveraging HCX Plus. And again, HCX Plus is a new emerging product that we offer. It is a SaaS offering allowing you to easily stand up HCX for migrations across your cloud environments and leveraging this very underlay networking architecture that I outlined before to move these workloads. So we're going to start out here. We're going to create a new mobility work group. And we're going to define our source and target site, the one data center being in Paris, other one in Palo Alto. We're going to migrate this CRM test application. We define our destination network that it's going to reside on once it gets migrated. Click Next here. And you want to validate all the configurations. You can migrate certain settings like tags and stuff for the workloads if you want to. And then we're going to start the actual migration. So the SaaS offering, you can see the UI here is a little bit different from the on-prem version, I would say. And you can see some errors here and alerts, and it shows you that the actual migration is in progress. Next, we're going to go to the actual events tab and kind of verify the actual replication has started and it's starting to migrate the actual workload to Palo Alto data center. So that's in progress there. Just going to work through that. I think I'm going to speed this up a little bit. Okay, so now it's at 41%. And then we can kind of refresh here and verify that it's the switchover has started. Okay. So validate the migration. It's going to work through the migration still. Super easy. And again, a lot simpler than the on-prem version. So managed for you. Okay, so now we're going to validate the actual migration is completed. So we're going to go log into the actual Paris vCenter. And we're going to validate that CRM application is moved. And then we're going to log into the actual Palo Alto data center after this. So we're looking at Paris right here. So that VM's gone. Okay, now we're in the actual Palo Alto, and there the VM is now in sorry, this is Paris. This is still in Paris. Validating that. Yeah. So you can see there in the logs it actually moved over. Migration is complete. And that's it. That's it for the actual demo itself. So just some closing thoughts before I part. I want so as you look to enable your multi-cloud networking, understand your options and plan for connectivity. Obviously, the IP scheme is key. Make sure that you have the right IP space planned for scope and growth across the networks. Unless you're evacuating a data center, think of the cloud as an extension. Try to take those same operational skill sets and tool sets that you use for your existing data center and keep those in place. Obviously, you need a reliable connection. Make sure you think of redundancy throughout when creating this mesh connectivity. And then I highly recommend leveraging NAS providers if you can, if they're available in your location. They will greatly alleviate the connectivity to these different cloud environments and streamline the operations as well. And if you can't leverage NAS providers, another option is SD-WAN. SD-WAN is a great option. A lot of great products there that we offer. Ours is VeloCloud that you can leverage to kind of save costs and get the same benefits. And then again, have caution when extending layer 2 into the cloud. Only use as needed. We see a lot of challenges with clients leaving layer 2 up and extension into the cloud, having lots of problems with that. So once the migration is complete, make sure you bring it back down. And then obviously, route traffic as much as possible. Layer 3 is king in the clouds, so leverage it as much as possible. And that's all I have. And I want to share some links with everyone. If you want to learn more, there's a multi-cloud network connectivity write-up that we have on our site that can walk you through creating the mesh network across using Equinox. And then the reference architecture link there that I shared earlier. And a link to our team site, the Multi-Cloud Tech Zone, You can look at articles and find out more about our cross-cloud services outside of multi-cloud networking and in addition to multi-cloud networking. So please take your survey and provide feedback on this session. And thank everyone for your time, and I hope you enjoy the session. Thank you.
Good morning, everyone. My name is Siddharth Swami. I am working as a regional technical sales consultant for Gulf Business Machine. My topic for today is VMware Hybrid Cloud Approach. Before I start my topic, I would like to ask you, how many of you have been into a space where you have to manage multi-cloud or hybrid cloud in your environment for your customers or you being as a customer? How many of you manage that? Some of them. So, just a minute. It's not good. Okay. So this is the space where we see most of our customers today. If you see, customers have their own premises data centers, they have public clouds, they have edge locations, and they have DRs. On top of that, there are applications which are running on it. And each application is best suited to run on a particular platform. These applications are further managed by a distributed workforce and then are being accessed by the customers who are spread across the globe. As you can see, this is a very complex matrix to manage. And when we speak to most of our customers, we identify that multi-cloud is not a situation where they have given it by choice. It's a situation where they have landed into. And given every day, it is becoming even more complex to manage because of the complexity of the application or the requirement which each application needs to fulfill. Now, how do we solve all of that? Now, if you see from a multi-cloud perspective, right, this is what a true difference between multi-cloud and a hybrid cloud looks like. Customers have their on-premises data centers and they have footprint in pretty much every public cloud domain. Applications are installed in each of these silos. And most of the times, these do not interact with each other because they have different set of operational tool to access, and sometimes it is impossible for any application to withstand multiple footprints at the same time. This is where we call it as a multi-cloud environment, but it is still not a true hybrid cloud infrastructure. And as we have seen, right, as of today, the requirement of a hybrid cloud space is becoming even more demanding. Now, when customers are setting up their hybrid cloud environment, there are a few challenges which they have to address before they identify or strategize their hybrid cloud strategy. They have to ensure that the operational inconsistencies are taken care because each cloud operates in its own. They have their own set of tools which requires them to operationalize. There are different skill sets which are required to manage all of it. Somebody who is expert in AWS may not be as equally expert in any other public cloud and vice versa. Then there are different security mechanisms which each public cloud has in their own space, and sometimes they do not match with each other. And finally, every cloud platform has their own machine form factor, and when you are migrating your workload from one cloud to another cloud, many times you have to do that refactoring of the virtual machines as well. Now, all of that, it decreases the overall agility of your hybrid cloud approach. According to a survey, it takes almost 7.5 years to migrate close to 100 applications to cloud with a refactor form factor. It increases the overall risk of managing this operation because it takes too much of time, and needless to say, it's a costly affair. And many times, organizations do not get into a situation where their overall operational cost becomes too high to manage. Now, how do we manage all of this? The solution to this problem is a VMware hybrid cloud approach. It starts from your on-premises data center, where your compute, storage, and network is being virtualized through the well-known software solutions like vSphere, vSAN, and NSX. Top it up with the ARIA suite, which gives you the cloud management. And then this entire ecosystem is called VMware Cloud Foundation. This form factor is available across the hyperscalers, whether it is AWS, Azure, Google, Oracle or IBM. This creates a complete consistency in the landscape, because now you do not have to refactor your workload. It is the same platform which is spread across all the hyperscalers. It gives the customer a consistent operational model where you do not have to learn a new skill set, or you do not need a separate tool to manage each of the space. It also gives a consistent infrastructure where the VMware, vSphere, vSAN and NSX, which we all are well familiar with, it is available across your hyperscalers. So when you are doing that migration, it is not a great learning curve. In fact, when you are doing a migration, it is more like a vMotion for most of the administrator. And in your vSphere console, you see it as an additional vCenter server. And the entire model is built upon an intrinsic security framework. So that means it is completely secure. It is built on the framework of your secure infrastructure. This is what we call it as a true hybrid cloud approach. Now, although this platform is available across the hyperscalers, but just for the sake of understanding, let's look at one of the example. This is called VMware Cloud on AWS. So basically, there are bare metal servers which are placed inside AWS Global Data Center, and they are used for the cloud extension. On the left hand side, you see this is a customer data center, which runs the proprietary VMware solutions of vSphere, vSAN, and NSX. On the right hand side, in amber color, this is the AWS Global Data Center. Inside these data centers are the SDDC stack, which runs on vSphere, vSAN, NSX, along with Tanzu and Aria. And this is further extended to your on-premises data center. Consider it like an additional vCenter server which gets attached to your on-premises data center, and exactly it is that simple. Now, since this platform is residing inside AWS data center, that means you as a customer have access to all the native services which are placed inside that public cloud, whether it is S3, Lambda, or you name it. Now, it gives a complete operational consistency, and it is a completely fully managed solution where you get all the benefit of your public cloud native services as well as your private cloud infrastructure. Now, although the offering is similar in all the hyperscalers, but since VMware Cloud on AWS is a jointly engineered solution by VMware and AWS, so it gives some key use cases. Customers can use this to do the seamless migration. They can just do the bulk migration, or they can perform a hot and cold migration to the cloud data centers. This entire solution is offered as a service to the customers. That means entire day 2 operations, upgrade, updates, hot fixes, everything is taken care by the VMware team. So you as a customer do not have to involve into a day 2 operations. It's a completely consistent infrastructure. It is the same software stack running in cloud, the same which you are running in your on-premises. So for you, there's a zero learning curve in terms of learning a new skill set. It is completely portable, and it is the platform which is certified to run the modern applications. It contains the Tanzu Kubernetes grid, and all the elements which are necessary for you to run, build, and manage your container-based workload. Now let's look at some of the use cases which customers are popularly using this hybrid cloud. The very first thing is disaster recovery. When I personally talk to customers, some of the financial institutions, for them, it's very important to perform a DR operations at a particular interval of time across the years. And DR most of the time is considered as a passive resource. That means customers have to hugely invest into setting up a DR infrastructure, which is exactly same as their primary data center, but they hardly use it. It is considered mostly passive. This is where VMware Cloud and AWS plays a very important role, where you can use it as and when you require. Customers also use it as for their data center extension. That means, let's say you are a retail customer, and then you have a Black Friday sale or any holiday season coming up. So you do not have to invest into the OpEx, right? Into the CapEx. You can consume the service and extend your workload as and when it is required, and you can bring it back. That's the whole beauty of a hybrid cloud. It gives you the flexibility to go to the cloud and come back as and when it is required. Customers mostly use it for the cloud migration also, where you can migrate or evacuate your complete data center onto the cloud and then do the day-to operation or maintenance of your on-premises data center. And when everything is up and running, you can bring everything back. And that way, the downtime for your production application is very minimum. And finally, as we said, that this environment is certified to run next-gen modern applications. That means you can run your Kubernetes-based workload natively on it. In fact, I have seen many of the customers who are using this to consume the cloud services from native hyperscaler and then run the Kubernetes-based workload on hybrid cloud, VMware hybrid cloud environment. Finally, let's look at how does this whole looks like from an overall complete stories perspective. You have a legacy data center, and this legacy data center is further modernized in the form of VMware Cloud Foundation. We have spoken about it. This is a form factor offered by VMware with the proprietary set of software suite. Once customer migrate this to the VMware Cloud Foundation, it gives them the flexibility where it can resonate with any of your data center. It could be your on-premises near DR, it could be your co-location DR, or it could be placed anywhere. It could be a robo location, right? And using the hybrid cloud extension, customers have the access to migrate the workload from one place to another place. It gives them the seamless portability where they need not to lock in into a particular data center, and the workload gets the freedom to move as and when it is required to be. Since we have spoken that the same set of software suite is available in all the hyperscalers, that means this VMware Cloud Foundation suite is available across the hyperscalers. Using the hybrid cloud extensions, customer can migrate this workload from their on-premises to any of the hyperscaler. The solution which each of these hyperscaler uses are, as we spoken about it, for AWS it is called VMware Cloud on AWS. For Google it is Google Cloud VMware Engine, GCVE. With Oracle it's OCVS, and with IBM, Alibaba and other hyperscalers the solution remains the same. That means customers get the flexibility to move their workload as and when it is required. And this is called a true hybrid model where the workloads decide where it has to go and the application becomes the owner of the platform, and you as a customer gets the flexibility to migrate your workload as and when it is required to any of the hyperscaler. Because as we all know that it is the time where application decides the platform where they want to get themselves placed. Not every application is best suited to run on any platform, and not every platform is best suited to run every kind of application. With that, I end my presentation. Thank you so much.
2. Gentlemen, good morning. VMware Explore 2023, same guys, same topic, new session. So we're again talking about cloud directory design, do's and don'ts, and maybe we share one or two fun stories around the whole thing. So the agenda with us, we do a brief introduction of ours, then we dig into the topic, and maybe a wrap up. We'll see. So I start with myself. My name is Matthias, partner at Comdivision, mainly focused on the cloud directory stack, so the cloud stack, VCD, NSX, and VRO, so the whole automation around the whole cloud directory stack.
Yeah, thanks, Matthias. My name is Toby. As Matthias already mentioned, focusing on the whole cloud stack, primarily the whole NSX and cloud networking story. Also partner at Comdivision. So let's do it quick and easy. Who are we? Who we are? Comdivision was founded in the 90s. Our main focus nowadays is clearly on the whole VMware portion. So we are focusing on the whole VMware products, but also nowadays truly being a multi-cloud partner, so focusing on VMC, on AWS, Google, and stuff like this. What are our 3 main business areas? Architecting a solution, operating the solution, and support the operational teams. And since most of us are also VCIs, we are also a strong relationship to the whole education.
All right, that was a brief introduction. We start with the same sentence every single year. The worst idea is having no design at all. Even a bad design is better than having none. Today we're going to cover building blocks versus sites, because we think it's interesting and funny. We cover standardization, allocation models, again, yes. IP spaces, because it's new and fancy. And last but not least, today, that's the big surprise, we're talking business. Oh boy. So we talk about build consumable products. Why? Because we saw that many CSPs are struggling with that in the last year. That's why we start talking business, but just a little bit. What to consider, what to ignore. First of all, infrastructure. Why infrastructure? Because it's underlying the building blocks. So we still have vSphere. We need to consider cluster size, amount of clusters. Should we use a distributed switch? Yes or no? We're still struggling on that one. And which storage are we going to use? Traditional storage, like shared centralized storages, independent of the protocol, or are we going to leverage vSAN? What is still the biggest concern about vSAN? Cost. Because VMware is still not able to provide a proper cost model for CSPs around the whole vSAN. Let's dig into it. Building blocks versus sites. What is a building block? It is one consistent or one repeatable piece of infrastructure which I can use over and over and over, identically. So it might consist of a vCenter. That's one of the questions in the design. Start asking yourself, what are the components of a building block? Am I doing vCenter per block? Yes or no? We always have to have ESXi hosts, otherwise it's not working. Are we going to have one NSX manager per building blocks? What's our considerations around that?
Yeah, what would you like to achieve? Is it fine to have NSX stretched across your provider VDCs? Or do you say, hey, no, each building block should be this dedicated solution, this dedicated provider VDC, and I don't need to stretch my workload across multiple provider VDCs. Now, with the latest release of VCD, we have now finally got the support for federation, but also then we need to consider, are we ready to go with federation? Is it really needed to go with federation? So if you're talking about a single site solution, do we really need to have federation, or do we say, hey, I have a single site, but I utilize my multiple building blocks, so it's fine to go with one single NSX instance, for example.
And last but not least, storage. So what are the considerations you need to think about before creating a building block? Cluster sizes, limits. Please always keep the limits in mind. Virtual machines per vCenter, for example. A few of you might think like limits. So a vSphere can handle that many objects, limits doesn't apply anymore. Guys, that's wrong. We had a fun story this spring, having one customer asking, what shall we do? Because we currently have 64 instances of VCD with approximately 800,000 virtual machines, and we struggle to manage. So it happens sometimes. So once we have created our building blocks, the next part are sites. A site consists of one or more building blocks. And that makes the whole design consistent and repeatable. You can build over and over and over. So these are considerations. Dedicated NSX managers, one vCenter, many vCenter. Shall we use enhanced linked mode between the vCenters? So take all those questions into account before putting VCD on top of it and start creating PVDCs. And always keep one thing in mind with NSX managers. Please connect NSX to VCD before you connect the vCenter. That's a typically approach I'm using, because if you create a PVDC and you forget to add NSXT to it, it's a one-way ticket to hell. It's still not possible to attach NSX to a PVDC if it's not later on. It's still not possible. So these are all considerations we need to cover. As Toby mentioned, network stretching, our networks per site. Which services are we going to offer to our customers? Do we have active-active, or are we providing DR services? So it's active. It's still active-active, but we don't have productive workloads running on both sides active at the same time. Network stretching is a complete different beast. Have you ever thought about GSLB?
Yeah, for example. So what can I get with GSLB? Global server load balancing. So I can achieve that I have multiple VMs running in different provider VDCs, different OVDCs, for example, and can have up in front my global server load balancer. Since we get more and more the support from NSX ALB into VCD, this is one of the next features which is clearly on the roadmap, so it will be there in the next couple of months. Yeah, dear Mr. Customer, you would like to have a multi-site solution? I can offer it now to you now.
What we saw in designs, so proper building blocks, proper solution design, talking, disaster recovery, active site, standby site, failover, tested, everything is working perfectly fine. But there was still one thing missing. If you have two sites, who's failing over the public IP addresses? So also keep the supporting layer on top in mind, because if you can fail over the services, but you cannot access them from the outside anymore, it's a useless solution. It's completely useless. So keep that in mind. So that's why GSLB might be one very interesting option to include in the design. The most important part of the design is discuss the available solutions or the choices we have with the customer. Otherwise, he might not be aware what's part of the design. But still, where's Cloud Director? So if we talk sites, we have maybe single site, multi-availability zones, but one site, or many sites, or multi-availability zones in multi-sites. The second important thing to consider is, where am I placing my VCD? We typically talk about instances. So one VCD instance consists of multiple cells, at least 3, please, 3. Always remember Monty Python, Knights of the Holy Grail, Holy Hand Grenade. It's always 3 at least. Have we one centralized cloud director managing all the sites? Or are we using one VCD per site? And the next step, please consider the implications we have. If we use multi-VCD instances for multiple sites, the implications, for example, are, as you mentioned, federation. So where is a customer logging in? How can I make the customer resources accessible to the customer? Is it a single pane of glass? Or am I proactively using multi-instances to provide a different DR feeling, disaster recovery? So what are my goals behind the whole solution? And that relates to the building blocks as well. Where are the vCenters? So vCenters are out of the equation because we have so many anyway. But where are the NSX managers? And that's what you mentioned already. Are we going to provide stretch networking for customers? Enabling customers to transparently move workloads between data centers or sites? Or are we not enabling customers doing that? It's a very important decision to make, and that is, again, part of the design. Discuss it up front. Another option is providing different services within a data center from an availability perspective, so we can have A, B, and stretch state check. So keep that in mind. Which SLAs are you providing to the customers? It's, again, same story over and over and over. Which design choices do we have? Which business requirement is related? Make a decision, justify the decision, and live with it. What is that leading to? It's leading to standardization. So standardization helps us to achieve many important things. So we start with consistency. Why is consistency key for the infrastructure? If we have the same building blocks being used over and over and over, first consistent feeling is performance. Each building block behaves identical, except we build those for different performance tiers, maybe faster storage solutions or faster CPUs, right? The next is repeatability. So if we use a building block and standardize that, we can deploy one building block after the other over and over and over and extend the infrastructure. And of course, easier maintenance and operations. And last but not least, there is always an operations team who needs to run the whole infrastructure. We need to ease troubleshooting. If we have hosts from different vendors, different storage solutions all over the place, it's very hard to troubleshoot because each vendor has their very unique set of tools, commands, and of course, behavior. Allocation models. You want to start with allocation models? Oh no, everybody loves allocation models. I always say, choose wisely. What is the most important thing if we talk allocation models? Never ever mix within a single PVDC. So today, Toby and I, we're trying a different approach to talk about allocation models because we all aware we have 4, but we're not digging into those 4 and how they are configured and their meanings. But what should we start off during the design phase of allocation models? What is the main difference between the models we have? We identify if we're going to configure the underlying vSphere infrastructure to do the resource management for CPU and memory either on a per virtual machine object, or on a per resource pool object, so a group of virtual machines. And the implication is, who's responsible of managing overcommitment? Is it the service provider or the tenant? And that's what you need to think about. Am I providing the ability to use overcommitment? And who is responsible of making the decision, am I overcommitting, yes or no? Overcommitment, performance might drop. And the vCPU speed, we love the vCPU speed because many just forget to design the vCPU speed and think about it. Most of the people forget to change the value, and 1 gigahertz is not really fast. So keep that in mind as well. IP spaces.
Yeah, new feature. Cool new feature.
Yeah.
We finally got the possibility to offering IP as a service. So this is what IP space is mainly for. There are two options available, the public IP space and the private IP space. So what is the main difference between those two? On the public IP space, is utilized that the service provider is managing it, and it gives us the ability that the tenant can consume public IP addresses. Automatically, he can request for IP addresses, he gets an IP address, and he can move on. And both directions or both spaces are there that you as a cloud service provider get your routing in a working manner, that you don't need to care about, hey, what's going on in my routing and how do I solve my routing issues, that this is be solved with IP spaces because the customer is only capable of consuming the IP addresses you give him in the IP space portion. What's the main difference between public and private? Public is working from an NSX perspective on the uplink interface from tier 1 to the tier 0 gateway. The private is utilized for downlink, or not really downlink, for the internal use in the consumers, in the customer space, for doing routed networks, whatever he would like to utilize. So this is the main difference between the private IP spaces and the public IP spaces. And last but not least, we now get the capability with the release of VCD 10.5 that we can migrate our legacy IP allocations to IP spaces. And this is also part of the whole NSX V2T migration tool now with the latest releases.
And that all leads us to the same story in the end. And please do not shoot the messenger, but I was talking the whole week business, right? That's very unlikely for me, but a few things happened prior to the conference, so I had to talk business the whole week. And that drove me to the idea, why not to talk business in a community tech session? Because we all need to drive or support the sales organization. I'm really sorry for that, right? No one has tomatoes or eggs or anything, right? So I'm perfectly fine up here. So build consumable products. Consumption is key nowadays. So more and more customers are asking their CSPs, could you please provide a service? What if a CSP is not able to provide that service instantly? Oh yeah, dear Mr. Customer, please allow me 2 or 3 weeks. I'll try to build it. So that's not a proper relationship because the customer knows exactly like, oh shit, oh beep, that was a beep. So he knows exactly they're trying to build it. They have no clue about it. That's not very trustworthy. So start digging into new technologies and start coming up with a product around it. I think the next main step is, sorry for that, Kubernetes as a service. Add, for example, CSE for one to your design. Be ready, be prepared to provide additional services. Get familiar with it. And as soon as you're familiar and you have a customer approaching you, dear Mr. CSP, I'm interested because I have a new application and the vendor ships it as a containerized application. Could you please provide a platform enabling me to deploy the new application? And you can select, all right, no problem. Here's the contract. Consumption is key. I just change the permission. It's available in the UI, and the customer is able to provision new Kubernetes cluster in self-service and managing those clusters himself. So design products, firstly, enabling the sales rep to sell it easily. Do not start building rocket science out of it. And have new technology being ready to run if someone needs it. If you create new product packages, and if a feature is not available in the UI, please always consider the managed service approach. What is a managed service? It's just who's responsible of configuring a service. Is it either self-service, so it's the tenant, or if it's a managed service, it's the CSP who configures the stuff. You know what's cool about provider managed services? I tend to charge more for it. Yeah? I'm a bugger, I do that. So charge more, provide those services if they're not available in the UI. Again, it is the same process because then you can offer it. I know many customers tend to compare smaller CSPs with the hyperscalers. And we are all aware we cannot compete with them. We need to build our own products, build solutions around the products, maybe if your customers are asking for me. For a few services which might be available in self-service, still consider if you should provide those services in self-service because of support. We all, as mid-sized CSPs, that's what I refer to, so not hyperscaler, we take care of our customers. So if they burn and fail configuring something, we're still there to support our customers. And if you provide, I'm so sorry, questions are not allowed, but afterwards we are around and we can have a short discussion around that. Last year I was trying to answer questions session and Alice there just chased me down. Lucky me, he's not here currently. So think about the support team. We had the fun with a CSP and a customer, and they enabled the distributed firewall for the customers. They had hundreds of tickets because their customers didn't understand what microsegmentation does if you configure the any block safe. That's really nice. So always have that in mind. On the other hand, if you build a managed service, be aware of the consequences. What if you provide distributed firewall as a service? So service provider management has a ton of implications again. Because what if you fat finger a firewall rule and you just kill a customer's application? I know, there is no solution saying A or B is better. You can choose between pest and cholera, that's it. Okay. All right, so in the end, it's always about the money. Famous last words, just being on time. That's Yves, our CEO. He's supposed to stand next to me, but obviously,
Looks a little bit different.
Yves got bold. So famous last words. Even if you build a really awesome technical solution, and if it's not related to any of your business requirements, it's useless. It just burns money. It makes the life of the operations team completely miserable because it's not manageable.
But it's still cool.
It's still cool, but it's not manageable. All right, gentlemen, thanks for your time. Enjoy the last day of VMware Explore 2023. It was great being on stage. Take care.
Take care, and we are around here.
Good morning, everyone. Welcome to this VMTN Tech Talk. Along with me, I have Iro. Iro, hi.
Hi, good morning. Thank you all for coming this morning.
Yeah, so this is a standard disclaimer that we always present. Take a look at it for a few seconds. Yeah, this is the abstract that we have submitted for this today's Tech Talk. So we'll be talking about IT's modern application platform and how it is helping our developers to fast track the application development to build, run and manage them, right? And we are also providing the self-service facilities to our developers so that they can, right, utilize the self-service utilities to get their resources. Okay, so this is the quick agenda. It's a simple agenda. So we will introduce ourselves. We will have this. We will see the scale of operations that we operate at VMware. We'll look at the digital transformation at VMware IT. We'll also look at the modern application platform, and last but not least, we'll also look at the CI/CD pipeline and DevSecOps. And then we'll open it for Q&A. Okay, so let's start with the introduction. My name is Mukund. I am part of IT, close to 11 years in IT, and managing the modern application platform as of now. Before that, I was working with Oracle and managing the Oracle practice. And before that, I was a developer in various small companies. So with this, let me hand it over to Iro for his introduction.
Thanks, Pukun. So my name is Jairo. I work as a platform engineer. We do work on basically having the platform stable all the time.
Okay, thanks, Iro.
Sure.
So let's move on to the next slide. So this slide depicts the scale of operation that the VMware IT manages. Right, these are very big numbers, but I want to highlight few numbers here. The number of VMs that we create and destroy on a weekly basis is almost like 1.5 million. You will find this is a very unusual number because this is in the IT. This is in the VMware, because all our VMware engineers, right, generally try to play around with the new products, and they develop the products, and during the development and testing of the products, they create this number of VMs. And the second number that I want to discuss is about the number of containers that are getting created and destroyed. These are almost like 3.1, which is double than VM. So this signifies that the world is rapidly moving from VM based workloads to the container based workloads, and this could be an immediate future for your IT as well. So looking towards this, we had been also building our platform, modern application platform, and we will go through this in subsequent slides. So before that, I just want to also highlight some of the other initiatives that we have been doing in the digital transformation. So we look at it as a three approaches to basically people, process, and technology. And apart from that, we also work on the policy as well as data. Right. So you must have always heard about people, process, technology, but apart from that, right, policy and data is also priority for us. So when it comes to people, we always try to make sure. Okay, let me. We'll make sure that they are understanding the SaaS first mindset of VMware. So and then we are also making sure that processes that we are using are aligned to the faster development of applications, right? And then last but not least, we are also making sure that the data is consistent across all the applications. So the master data management becomes very critical for our systems. And last but not least, the human touch is always there. We always try to think of human experience at the center of all our things. and then we'll look at now how we have built our systems to fast track the application development. Okay, so yeah, as I mentioned earlier, we have been developing this platform over the period of time. So before this 2014, that is 2013, we had 100% virtualized our workloads, and the biggest hurdle for that time was virtualizing the Oracle rack. So Oracle rack was running on physical servers, and then we virtualized it, right, 5-node rack, which is the e-business suite rack, and then all the order management systems were put onto like 100% virtualization. So after that, we were looking at what's next, right? So then the immediate thing came is about the Dockers in 2013, and then from that time we started looking at how we can utilize this Docker technology, which can become potentially disruptive, right, in the future. So slowly we started moving some of the workloads, right, converting our applications from VM based to containers, and then our first platform for cloud native applications was the PCF, or now it's called TAS, right. So this is the first platform that we introduced to our developers, which was running on 2 data centers. And that was highly available platform so that developers can develop their code and deploy into the cloud native architecture and applications. And then slowly, when this Kubernetes world came and VMware introduced the Tanzu portfolio, we started also building the TKG platform for our developers. So and eventually, you can see the roadmap that we have come, and then as of now, we have this modern application platform, which is mainly built using the Tanzu and ARIA products, is being given to our developers, and the TKGM is the de facto platform that a developer uses for the greenfield development and also for the brownfield development. Okay, so with this, let me hand it over to Iro to take you through the current state of the modern application platform that we have in VMware IT.
Sure. Thank you very much, Mukund. So basically, I'm pretty sure you guys have seen this PPT or this slide throughout the whole VMware Explore event. So basically, one of the applications or one of the most common applications we run for corporate business are like, we can mention Help Now, Source, Harbor. This is used by hundreds of users within VMware Corporation. Also, we have like Customer Connect, Skyline, Spring.io. These are applications that are worldwide used like by thousands of users throughout the world. So this is just to mention a few of our applications, a few of them of the applications that we do support in our stack: benefits, well-being, data, and much many others. The way we run them, or the way we structure this, is in 3 different stages, right? Manage, build, run, and self-service. For the build part, we have services like Spring Cloud Services. We have also Harbor as a Service, which is actually a very good container registry. I'm not sure if you guys have used that, but it's very good. We have actually 2 instances: Distribution Harbor, Corporate Harbor. The corporate is basically for the internal employee. Distribution is to pull and distribute the images throughout, different users, external users. We also use VMware CodeStream, VMware Application Catalog. That's in the build part. For the run part, we have different platforms like TKG, or Tanzu Kubernetes Grid, which is basically our flavor of Kubernetes. We use that. It's extensively used. It's very well accepted among all the developers. We also use TAS, which was formerly Cloud Foundry, or PCF, what you call. TAS is also a very stable, very good platform. It has a lot of benefits. That's 2 of the main platform applications we do support in our group. We also have vSphere with Tanzu and VMware Tanzu SQL. So we offer those services, and they are out there. In the managed part, we use things like Tanzu Mission Control, vRealize, or ARIA, which we are all familiar with right now, Observability by Wavefront. All those tools. Tanzu Mission Control is actually a very well tool, so you can manage your cluster, you can onboard your cluster to TMC, and regardless of where your cluster is. It could be on-premise, it could be on the cloud, it doesn't matter. You can just add the cluster to this tool and you can use it there. And also, we have self-service. Self-service portal is actually a very good tool. It doesn't make sense, right? If you are creating one application and you need to request for ticketing and so on and so forth. So self-service tool is an automation tool where you can request your namespace, you can request your corporate hardware, and that's it. Actually, I was part of the development process, and I can tell you that's a pretty good tool. Now, thanks to application service. I'm going to be quick here, but just for you to know, the right side of it, it's basically the vCenter, right? Let's say we have three foundations: Foundation 1, Foundation 2, Foundation 3. This is vCenter. This is inside one vCenter. Each foundation will have a T1 layer. It could be infrastructure subnet, deployment subnet, you name it, all right? This is TAS, okay? This all will be managed by the Diego brain in the case of TAS. We can have many T1s, and there is a T0 associated with it that will have communication with the T1s, okay? This is NSX part. Again, everything runs on VMware, all right? So T1, T0 will be managed by NSX. Then at the other side, we'll have the internal firewall. We'll have the NGINX. The NGINX will have some routes configured in the NGINX configuration file. So we'll talk, of course, to the internal firewall, the T0, and then the T1, and subsequently to the application or to the container where the application is. And at the end, we can have the external firewall and the CDN, right? The CDN could be Akamai, many other solutions we have. So this is a very well infrastructure we use, and this is very well accepted, and this is also very stable, and a lot of users really loved it. Also, we have tons of Kubernetes Grid. I'm not going into much detail. We have actually 2 data centers. We have one in Santa Clara, another one in WDC. We have also the self-service portal. Because of the time, I'm not going to extend much. The self-service portal, this is where you can request namespace, organization, corporate hardware, distribution hardware, you name it. You can do it from there.
Yeah,
This I'm going to pass.
Yeah, and last but not least, right, we have the CI/CD pipeline, right, which is built using the vRealize code stream. Yeah, I think this is the last slide, and yeah, feel free to reach out to us for any questions that you have, and we'll be more than happy to have a deep dive sessions for any of these topics in the future. Sure. Thank you.
Welcome back to VMware Explore 2023 in Las Vegas. Thank you for joining us today. My name is Tony Foster, and welcome to the session on AI on the Horizon, delivering virtualized AI environments to students. So I am Tony Foster. I'll be your presenter today. I am an adjunct professor at K-State University in Kansas. I also happen to work for Dell Technologies as a technical marketing engineer. That's my primary job. And today we're going to talk about delivering virtual AI environments to students so that they can actually work on AI as they go through their schooling and gain experience they need to actually administer an AI environment. We've got a lot to talk through. I originally submitted this session as a hour-long session, so I'm packing an awful lot of stuff here into 12 minutes. So, what we're doing at K-State, we're going through and wanting to deliver AI to our students. That way they can actually practice managing it, working with it, building models, training models, all of these different things. And we're actually starting small. We're starting with a single class just to make sure that we can do all of it and make sure that we can validate all of it. And we're starting with our CMST 180 class, which is Intro to Database Systems. We are going to have our students go through and manage databases with a GPU backend. So, there are a few things that have to go along with that. We obviously have to provide them with a management experience where they can go in, they can see the GPU, they can pull all the stats and everything. It has to be an isolated environment. I don't know of anyone who'd be super excited about turning students who have just started working with databases loose on a enterprise system. So you want to have it isolated. This also has to be able to be addressed by both traditional on-site students and our global students. So we have students coming in from all over the earth taking our classes, and we want to make sure that they have the same opportunity as those students who are on premises have. And so we're making that accessible to all of them, and we're doing this with minimal IT resources. Yes, so because this is a pilot, because I only have a few resources to work with, I'm building this with extra stuff left over in the lab. I have about 3 servers, and we'll talk about the environment here later, and a bunch of GPUs that are left over from a program we had earlier on in 2020. So there are some other constraints that go along with this. Like I mentioned, this is a trial only. So we're just trying it out. We're making sure we can actually do this. And so far it looks like it'll be successful. I mentioned the existing equipment. We have to do this from the VPN. So our students can hit the student VPN, log in, and be able to reach our labs. And we're just going to put a VMware Horizon portal up there, and they just go to that web address, and they'll be able to get to it. We're not putting it out on the public web for them to access, and the primary reason for that is we're trying to minimize our impact with IT and having to do a bunch of certificates and stuff. So we're going to actually keep it inside. We're doing a small group, 8 to 10 students, and we're going to deliver both Ubuntu desktops and Windows servers to our students so that they have the full breadth of being able to work with these database servers that I've talked about. The other constraint that goes along with this is this has to promote learning. We can't just go, okay, here's the 180 class, y'all go in and do your database thing. We have other classes that are in the labs and everything, so we need to make sure that those students are able to learn from this environment as well, and be able to understand the networking that's going on, understand the administration of these systems. So even though this is targeted at 180, other classes such as our system administration class will actually be tapping into this environment to learn to administer it, learn to configure some of the things that are going on in the back end that the database students won't be touching this semester. And above all, I have no budget. At least not yet, not until I can prove that it works. So, you might be going, well, why don't you just do the traditional thing, give all the students a server and let them have at it? I don't know how many people have tried to get GPUs recently. I don't know how many people think that it'd be easy to give $1,000 GPUs or $2,000 GPUs to each student to let them work, but those traditional approaches don't work. They're not feasible to do. They're not reproducible. So if a student messes something up, and I'm sure everybody here can say, you know, when I was in college or when I was learning this stuff, I never messed anything up. Nobody raises their hand. I'm not shocked. So it's not repairable, it's not reproducible, and it's not provisionable. We need to be able to provision these. We need to make it so that our faculty can go in and build labs for the week or for whatever time they need and can just punch those out to the students real quick. So there's a better solution to this. And that better solution is VMware Horizon. We're going to be delivering virtual desktops to our student. We're able to templatize all of these things so we can instantly address needing to be able to repair an issue if a student messes something up, or punch out new labs each week for the students, or whatever. We have isolation, so every student can have their own separate desktop. They can have their own separate GPU experience. They can have their choice of operating system depending on what they're working on. They get a slice of the GPU, which is wonderful, and we can use different technologies depending on whether or not we need balanced shares or not. And they can get better GPU utilization for all of the students instead of trying to figure out who gets what. So, that said, let's get into the meat of this. This is what we architected for the physical environment. We have a couple of Dell R740s. Each one of them contains a V100 GPU, because that's what I've got right now. Hopefully this will be growing. They're connected via a pair of mesh 10 gig switches. They all have local SSD storage in them. So to start with, we'll put them on SSD storage. Hopefully here at the end of the semester, I'll be able to get at least another R740 so that I can actually expand this out and do a vSAN cluster. And then we have an old SAN, and that's actually where we're storing a bunch of our image repos and stuff so that we can pull them in on the databases once the students start learning how to do all of that. And then of course we have a cluster management, and our cluster management is isolated. That way we can focus all of the resources on the R740s for student learning so that we can really boost up the memory for the students and give them the maximum number of processors we can. So here is the logical view of what we architected. We obviously have our internet down there with the students. They come up through the K-State VPN, or if they're on campus, they can just log in from any system on campus. They go through our firewall and they'll hit a connection server. Then they'll get the choice of what virtual machines they want to use. We've got the Ubuntu ones and we've got the Windows servers. All of those will have vGPU profiles attached to them, and they can go in, select what they need, and start working on those right away, doing large language models or anything else that's going to be covered in the class. Obviously, large language models won't be covered in the database class, but it is one of the things on the future roadmap. The student experience is exactly what you would expect from VMware Horizon. any device the student has, and they have them all, I've seen them all in class, they hit the K-State VPN, they hit the lab portal website, and they just select which virtual machine they want, and it's like they're working on a virtual machine. And there's nothing like showing a student a Linux desktop that appears to be running on an iPad. It blows their mind, and then they start getting to work, and it's an awesome experience for them. So, there are a couple of stumbling blocks you need to be aware of if you're looking to do this. So, you want to have your environment licensed for NVIDIA AI Enterprise, not virtual workstation. And there's an important distinction there. AI Enterprise is geared towards these larger cards and doing AI workloads. Virtual workstation is geared towards delivering a graphical experience. And the A100s, I know I'm using the V100s, but this is an important note, don't have display heads, which means you can't use the graphical features when you're doing Horizon. Also, we're not doing linked clones because in linked clones, it asks you about what your GPU profile to use and everything, and it doesn't quite work out right. And then we have Active Directory. We're not linked to the school's Active Directory system, and that is intentional. So, current state of the environment, it's built, it's working. I have configuration of the base instances to finish up, and getting the teachers to tell me what they want their templates to be. Then I have to get K-State IT to actually give me my DNS entry to let everything out of the firewall so that the students can get to it. Future state, we're going to expand it. AI Enterprise is going to be on there. We'll get VMware Horizon licenses, actual ones instead of the demo, and additional hosts and GPUs to work with. So, with that, thank you for joining me today for this very abbreviated session. If you have questions, see me off to the side or hit me up on any of these.
Hi, I know it's the last day, everybody's tired, but I hope expecting some news or something in a different way. Thank you for the time. Okay, my name is Waldemar Pera. I'm working with the Network Security Lead Architecture for VMware Latam. But today, I was talking about how is VMware security, all security in a multi-cloud world. It's not product by itself. try to see the problem end to end and understood what is really, don't go in deeper in each product. So try to follow where VMware is security for each point. Okay, let's go. I'm going to explain you what is the multi-cloud world. You know, where are you running your personal email? I don't know. I go to the URL, taking the information and use it. So the problem when you statize this dispersed environment execution is how the security follow that. That's the most critical. Maybe you remember the problems when you try, especially when you starting talking different executing environment, when they are talking about the cloud. By the way, cloud is not a site, it's an operational model cloud. And that was included on the hood very deeper automation. And the security needs automated. Without automate, you lost, you have more risk, you have challenges. Maybe the main trouble is the high risk for that case. Talking about the security, multi-clouds have other views, but for today in this session, it's about security. So high risk is a problem for the organization. Sometimes the people thinking is thinking only in the tools. So starting create a complexity. Different tools for different BIOS, several consoles, and sometimes and the question, how wise or level of security, I don't know. Because it's not easy, it's just spread the problem. So we need to go back and don't thinking in the tools, thinking in the problem of the security. What is my target? What is my security information objectives? And that is the idea, maybe, and repeat, is not a place, it's a way would include very deeper automation. If I take in that automation, I can provide a better, improve my security. Because I don't go back or don't create an add-on to the security. Every workload would live, born, still security. But it's one part, because in the other part, you have the users also. And you don't know who, or where, or what device uses that user, and you need to secure that user. And that's the other way. Sometimes the people thinking in the environment, in the application, and forget the user side. When you see, say, for example, you did a picture. How human you see in that building car right now? You see some human? You have a car? You drive? When you safe driving the car, you human touch. For decades, for years, I use cars building for machine. Automation. What happened in us? It's a mindset. It's a mindset problem, not technology problem. We need to change that. And when you see that, the big picture, and again, it's not the tools, it's the security information objectives. And you can go back. I don't think like firewall, the IPS, the anti-malware. No. What is my objectives? Because the environment changed. I don't explain what happened last year with the pandemic. Changed everything. So, but the security preserves the same objectives. We need thinking in high level, and depend what is my environment, select the right tools. No thinking if I had a hammer, everything is a nail. Wrong way. When we're talking in double days, I need to split the problem in different spectrum. Starting with first, the application side. First, you don't know where's running your application. When you use every SaaS service, you don't run it in a URL, you don't know. And at the same time, you don't know what kind of application you have today. Because sometimes you have legacy application, you remember the web, middleware, and database, and now go to the Kubernetes Cloud Native where you have a spread microservice around. The problem in the security is the same, but the tools, not. But you need to fix it, but because the organization uses usually both and more. When you see that, Usually in the security minds is as the outside world, the perimeter, and the inside. Okay, it's true now with this? You believe really you have a border perimeter, what is the outside world and the inside world? That is true? No, that is true. You need a distributed security. Follow the endpoints. Why? Because you don't know how connect endpoint between them. Only you know you have some kind IP network, nothing more. It's not private network, it's not network, I don't know. So it's any, when you say any cloud application and any network, follow the sun, follow the endpoint. And when you start in seeing, I see a lot of things around. And what means security in that case? The problem is secure data security. It's again not focusing on firewall and APS and WAF. Of course, use of tools, of course, but need my mind. I need protect the data. That is my target, not the tools. And believe me, it's a problem, classic problem. Why? I am humans. Go outside the zone comfort is not easy for us. When you take control and know and you try repeat and repeat the hammer, but not always necessary. So other question, usually people think private versus public cloud. It's the idea. You see that it's the classic problem. But what is private public cloud? It's just an execution environment. Where is possible running VMs or where is possible running Kubernetes. So the real differentiation is that. Talking about modern and legacy application. Why? Because the security object is the same, but the tool to apply is different because the environment is different. It's not hammer, it's another tool. When you think, let me starting with the traditional application. The big problem with that, usually when they start in virtualization, compute, VMware starting 25 years ago, but you have all, what's the problem? Classic, when you have bare metal, you have the port. You have the port, you have the control. When you go to the virtual machine, the port in the physical is nothing, it's aggregation ports. You have a lot of traffic maybe inside the site by the host by itself. I don't see it in the network. If you starting to blind, what is your comfort about what is you know about the security if you don't blind? You need to change that. Why? You can stop what you can see. You can protect what you see. The first rule for the security is see. Because if I see, I am aware. And I am aware, I have the chance to take decisions. When you fix things, you need change now. Because if you're thinking in classical tools in the physical way, that's okay. In the time bare metal server, you lost a lot of traffic vision. And you change that. So thinking the hypervisor, not what the stopper for the security. Taking the hypervisor was the opportunity to see everything. And that is possible. Today, with us, with vSphere, with NSX, you had the chance to see all flows or all connection. Is possible? Yes, it's possible. So, okay, I had the first step, see. I had the control. I had the possibility to see, for example, some case. You know ransomware problem, classic ransomware problem? Yeah, the people say, oh my God. I lost my database. That's my problem. Sorry, you see the last stage of the problem. Maybe this problem starting 6 months ago with Waldemar in the last important user in some far away the data center, reading an email, taking a click in the email, and leave a station for bad guys. And that's what guys, sleeping. Some moment starting to discover in the network. And starting the sham. No, but Waldemar, don't go to database. No, no. For example, you have Active Directory. All users connected to the Active Directory. And usually the Active Directory connected to the other things in the back end. The more common sham box for the lateral movement is the shared service. Example, Active Directory. So you have some way. And when you start in that, the second part is I had IPS. Yeah. But you know the more common lateral movement is not malware by itself. It's user right tool, legitimate tools, LDP, SCH, to connect between that. IPS, see that truth application. But it's okay if the database administrator go to the database to handle the database. But the middleware server go to the database and it's suspicious traffic. If I see that suspicious traffic only in my work, human work, it's a lot trying, and then it's suspicious traffic. I need thinking different, machine learning, artificial intelligence, to take in context not only the suspicious traffic, what happened around to understand all that flow. Because if you forget this point, the suspicious traffic, you lost potential, the more worse problem to see, because it's legitimate traffic. And when you that got, you thinking in that solution. For us, I'm working selling that, but this is true. 2020, I was testing the solution NDR, and the first was the first product with this precision. And this is real malwares, ransomware in the world. No something to test it, that is real. And that was fixed. You think that the next year, in the conference, we are again the top in the year. But in the same time, the endpoint security solution, Carbon Black, is included. And this last one, that all VMware spread for the end to the application are in the middle warners. Okay, so you have things to think. It's possible running, yeah. And what happened? No, because I tried taking in my own premise and move that for other place. My car, but you know you have VMware bubble running in each hyperscaler you prefer. It's VMware Cloud. Doesn't get the name. Azure V1 solution. Google Cloud Virtual Engine, Oracle, but in the sense, vSphere, vSAN, and SCX. So you have the same concept with Cloud Foundation in the premise, the private cloud, and the same concept in the hybrid cloud because the operational model is exactly the same. But I can't go to the native public cloud. Yes, of course. You go. Some moment you need come back. It's easy to onboard into the public cloud, but thinking it's not easy directly outside the public cloud. When you think things, you have VMware environment in each place. So go to the VMware. So in the end, you have a bonus. You have two-way movement. It's possible to go to that hyperscaler, and tomorrow I don't like it because money, whatever. It's possible move it, and you know it's possible. Preserve the classification, the tags in the security. Yeah, you have HEX, preserve the tags. And now with NXS Plus, it's possible running the same rules in the on-premise and the VNC, and next move to the rest of the scalers. So a single way to polish the manager rules in everywhere. So you have enough to select the site and preserve always the security. So go other part, the modern apps. When you think in the modern apps, this is the classical application. Web, middleware, database. But in the Kubernetes, you don't see 3 elements. No, you see that. A lot endpoints, and a lot ephemeral endpoints. I don't have time to create and go to put the security. I need the endpoint created with the security myself. And when you're talking that, my question is again, what is my new endpoint APIs? A microservice move it. I will say, I don't move it IP packet. I move it URLs. I move API between that. So I need thinking the flow now in API way. The concept is the same, yeah. My problem is visibility. How feeling when you taking a Kubernetes cluster? You see ingress and egress traffic. What happened inside? You know? Or you think it's a black box? For the security, terrible. I see starting visibility. I need to see happen inside the cluster. Also, I need taking visibility and taking remediation. Is see before what? Because you need see all the conversation. Is the same you talking about VMs? Yeah, exactly. The problem is the same. The tools not, because the tools need to adapt to the environment. And when you do this, the second part is handle the life and that solution. What is the security of the Kubernetes cluster by itself? You need enforcement. You have a lot of tools, for example, for Camel Cloud, to handle the cluster by itself. Because I need who is possible to connect to the Kubernetes cluster, who is possible to deploy, or is the image right or no? You have a lot of things around the Tanzu portfolio for that. In the same, you change the tools, but you preserve your target in the security. And what you say in this moment, I see a picture, and you see that it's Tanzu Service Mesh. What means? The possibility to running in a single console, in this dispersed cluster Kubernetes, in on-premise, on every native public cloud Kubernetes, and talking to, I need something to connect this point. Okay, Waldemar, let me go. To the API, I see all connection, visibility. I see what happened. I see what happened inside the cluster Kubernetes or what happened between cluster Kubernetes. Yeah, I'm starting to see. And the second part is, okay, I need the edit security API. And you see, okay, I had a source, I had a destination, and I have a service. Waldemar, a firewall that? It's the same concept. When you think in the distributed firewall, for example, but now apply it to the dispersed node. It's possible the same with Antria inside the cluster. Today it's possible with Antria, running Antria same AI, from the NSX manager create distributed firewall and mix in between virtual machine in pod in Kubernetes also. Recycle the ideas and change and adapt at the environment. The concept is the same. I select destination, I support, and it's like layer 4 rules, but it's possible to extend this to layer 7 rules. Real aware what's running. You thinking it's okay? Well, okay, Waldemar, but in this world, it's not only Kubernetes, it's not VM. Sometimes you have something ethereal, URLs, serverless. So you need that tools to control everything. In that case, I have the control for the working machine, I take control. But what happens in other kind of object I'm running in this multi-cloud world? What you're talking about, you have tools, and again, the same problem. I need C first. I need C to take in aware and then decide why protect them. And then, as again, the possibility to use tools from VMware for something running in native public cloud, something running in serverless, something running in S3 or whatever, and continuous auditing to see is wrong or good for this security view. And that is the idea. It's possible that, yeah, you have tools. Okay, I cover around, okay, other extreme, the user. When you the user, I can The same problem. You don't know where is the user, what kind of device is organization device, a personal device. You know, you have some generation prefer you personal device being your device. Is a stopper for the security? No, you need aware because you need that people prefer your device, but you need preserve the security of the organization. And you have a lot of things. And the first thing you already have a fabric to connect user in every place to where running the application. That fabric was EC1, the Velo Cloud, starting 10 years ago. And want to see the Gartner paper about SASE, talking about light endpoint and big resource in the cloud. That was originally 10 years ago with the POP to create a true fabric connection. Doesn't matter what IP network I have. It's internet, it's okay. And it's possible quality of service or experience for the user, yeah. And add in that POP now the security stuff. What do you need? Access. What do you need? CASB. You have the option. And when you're talking about that, that is the connect any user, any device, on any network to any application. The same thing talking before. Okay. So you have both sides, the part, you connect both, but what happens with the device by itself? I need to move it to the endpoint security. And when you go in the traditional way for the endpoint, talking about antivirus, talking about vulnerability management, but ADR, but it's far away now. You know it's in the office. I don't know where it's. So need preserve the security. The endpoint follow in any IP network. So you have solution for Carbon Black Cloud to protect the device by itself. Okay, but that is easy when the user is the device is my device, organization device. What happens when the user have different kinds of device? Or what happens when the device is a personal device and the user prefers the personal, but you need to select what is possible to see in the personal device or what is possible to see in the organization device. It's security in the side. When you're talking to, you have the possibility to handle different devices, a different policy for different rules for the device, and at the same time create and automate this way to produce. When that see, for example, you're talking about the zero trust, you're talking about the ID, three things, taking different way to define what is the user, who, you, yeah. Second one, the posture, the device. It's personal device, it's organization device, and you connect to the network, but because you need to connect that to connect the application. So you have the follow path in the endpoint that. And one more, you also, it's possible taking the location to define is accessible or no. Or it's possible for some application is just a single sign-on classical, or maybe require a second factor. It's my decision because I don't know where is the device. When you see all pictures together, you see the problem you have from VMware is thinking end-to-end. For each state in that connection, there's enough time for that. And you have now the possibility to take in more context information and translate that information in between things. That's VMware context. And leaving what is learning from the device, put above, and use that information to impact the network and a positive. That's the idea for us. A simple way to connect. You have a lot of people working in behind for us. Yes, we are a security company. This is the big picture. This is the resume. You have everything to connect. In each stage, when the end-to-end, you have security tools from VMware. So always you have power because you have different tools, but with backend handle information. That is context. If you like this presentation, you have a lot of things to find. But this, yeah, we are a VMware security company. Thank you.
Hello everyone, my name is David Santos. I'm a VCN systems engineer.
and today we're going to talk about infrastructure as code with NSX. So, what's infrastructure as code? It's a way to configure the infrastructure, in our case network and security, using a script. So, the benefit of infrastructure as code is that it's declarative. What I mean by declarative? In a single script, you can create many objects that will connect to each other, that will interact with each other. It's different than create a single object and wait for the response to use that response in another creation or another construction. In a declarative model, you can create your whole infrastructure or your whole construct in a single API call or in a single script. It is also iterative. By iterative, I mean repeatable. You can repeat or do the same task again as many times you need. You can also work with versioning. So you can create like infrastructure version 1, networking version 1, security version 2. And if you need to roll back, you can only restore your script and create the infrastructure the way it worked before. It's also composite, so it works like a Lego. You can build your infrastructure using multiple parts. So you can have a script for network, another script for security, and you can work with these two scripts together. It's searchable, so it's easy to find and replace things in the script. And it's also extensible. So you can use the same tool that you use, like Terraform or Ansible, to automate your NSX, your vSphere, your external load balancer, your external firewall, or integrate with AWS or Azure. So you can use the same script to interact with multiple systems at the same time. So why infrastructure as code? Because it speeds up and automates the deploy of repeatable tasks. So imagine that you have a lab or you have like a sandbox that you need to create multiple times. You can use infrastructure as code. Or you have a firewall template that you need to run multiple times. You can also use infrastructure as code. You can also glue together the application and the infrastructure in the same code. So create like virtual machines and also create the networks that they use, also the network firewalls and the load balancer, everything in the same script. Besides it's repeatable, it's stateful. So you can keep the desired state of your infrastructure. If someone messes up with the configuration, you only run the script again and it will go back to the desired state. Versioning rollback, it's something really cool because you can work with the versionings. Like in a firewall rule, if you have something that works and you want to deploy a new firewall rule and suddenly something happens and broke your application, you can easily roll back to what you had before and then get everything ready again. And it's also flexible because you can manage the infrastructure, the code, the way that you need. So let's start talking about with Ansible. Ansible is an open source tool. It uses YAML as a declarative language, so you can put everything or multiple things in multiple YAML files. It has idempotency, so this kind of stateful configuration, it will keep the desired state of your system. Ansible works with modules, so the modules are a way to interact with systems. In our case, we work with Python. In NSX, we work with Python, but you can use any language as long as they keep the idempotency to interact with Ansible. So you can use Perl, Bash, Ruby, whatever. As long as they keep the stateful, you can use the language. And Ansible also works with playbooks. So when you run a playbook, you run your script and configure something.
To work with the Ansible NSX is really easy. You can go to our GitHub repository and install the NSXT modules with Galaxy. And to use, it's only a single line, Ansible-playbook. You can use a dash V here to get more verbose. I also have the repository that I'm using here. It's public. And here we have an example of how it's an Ansible playbook. So in this case, we have our Ansible module reference. So we have the namespace, VMware Ansible for NSXT, and then the module that you're gonna use. That in this case will create the segment. So we have here the NSX credentials and also the states. So if you use present, it will keep or create it. And if you use absent, it will remove. And also the object details here of what you're gonna create. In this case is a segment. We can also work with the variables in Ansible. So we have our playbook, and our playbook will be referenced to a vars file where I can reference the display name of multiple segments, also the tier 1 that will be connected, the gateway address. And here in this configuration, I'm using Ansible to read a variable from bash. So I didn't want to put the IP address and the username and password of NSX, and I'm using here in the top a way to look up at the bash variable that will use to interact with my system. In this demo, we're gonna create 2 segments that will be connected to this T1. It's a really simple demo. And then we're gonna delete one of the segments and run the script again and see what happens. So I will run the script here. It created 2 segments. We can see here our 2 segments. Now we're gonna delete one of them and run the script again. And you can see that it kept one and another one it created. So this statefulness helps a lot to keep it in desired state. Now let's talk a little bit about Terraform. It's another open source tool that has been developed by HashiCorp. You have 2 ways of working with Terraform. You can use JSON or HCL. I particularly like HCL very much. It's easy to use, and it's also very simple. Terraform also works with declaring the desired state and also use CRUD, so create, read, update, and delete, the same way that we interact with our API. In Terraform, we have the providers that are the way that Terraform will interact with the system. And you have the modules. The modules are the script that you will create to manipulate the infrastructure or the system. To use Terraform, it's very simple. You have 4 main commands. Terraform init, that will download the provider and check if everything is all right. Terraform plan will show you what the script will do in your system. Terraform apply to apply the configuration, and Terraform destroy to remove everything. So here you have the files. Also, all these files are available at the repository. We have the provider.tf, and we're gonna use the VMware NSXT, is our official provider. We also have our main.tf file. What's interesting about Terraform is that you put everything inside the directory using .tf or .tf vars, and it will run everything that has .tf in the files. We also have in the main file have our script, the configuration file, and you have here the environment variables file, where I'm providing the NSX manager, username and password, and I'm also exporting those variables from bash. Here we have an example of how to create a segment and a tier 1 gateway in Terraform. Every time that I use a resource, I will create something in Terraform. So I will create a resource called tier 1 gateway, and it will use this command here to create our tier 1 gateway, nsxt polis tier 1 gateway. It will create a tier 1 gateway with name T1TF, and here I have a little description. Here I also assign a variable to our resource T1 gateway. That's T1 gateway there, and I will use that variable to connect my segment that I will also be creating. Here I can provide some info as like DHCP address, and the IP default gateway. And in this test, we're gonna create a whole infrastructure. So we're gonna create three security groups, also apply tags to VMs, the firewall rules, the 3 segments, the T1 gateway, and the T0 gateway is already created. So we're gonna consume that and create everything below this tier 0 gateway. So this is our demo. We have our T0 gateway already created. Here we're gonna grab what will be created. So we create segments, groups, and firewall rules. Also apply the tags here. Now I'm gonna run a Terraform apply, auto approve. We can see that it created everything. If I click refresh here, I can see that it created a tier 1 gateway and also 3 segments. And if I go there in security, I can see now that it created a security policy with all the security rules. And if someone messes up, in this case, if someone deletes some rules and also modify another rules, we just run the script again and you roll back to desired state. So I will publish this wrong version and run the script again. If I click refresh, the desired state of the configuration is back. And if I want to delete everything, Terraform destroy auto approve, and I will clean the environment as the way it was before. Click refresh, no firewall rules, and if I go to the segments, no segments. So, thanks everyone for watching. I hope I was on time, and I'm glad if I'll take questions offline. Thanks everyone.
All right, well,
I think I can officially say good afternoon now because it is 12 o'clock. So thank you for joining me today over the lunchtime. By the way, hope the lunch is actually good today. It's been good the last couple of days. So my name's Sean Massey, and what I'm calling this session is making the most of your home lab. So to quickly introduce myself, I'm a staff multi-cloud architect at VMware. I do a lot of cloud, I do a lot of EUC, I'm a VCDX, and yeah, I blog and other things. So today, your typical home lab session usually talks about how to get hardware and how to build it and put the pieces together. You know what? Way too many people have talked about that. So what I'm going to talk about a little bit instead is how to get the most out of that investment, right? Maybe you have the hardware, maybe you don't. Regardless of it, right? This is how to drive that value and how to make it worth your time and investment. So to start with, I did use this slide in a session on Tuesday, and it talks a little bit about learning theory. Right? Now, typically when we talk about technical training and certification, we're sitting in a classroom. There's a guided, or like a PowerPoint or a book or something that you read. And I say that those sorts of learning methods are a little bit more theory. And they're theory in the sense that we're not actually applying that knowledge. So they're good. You can get a lot of background. You can get of understanding how it should work on paper or how the vendor or the project expects it to work. But that's only part of the story, right? Labs are kind of the fourth learning style. It's hands-on. You actually get to tear it apart, make it work, and learn how it works in the real world as you connect things together with it. So I've had a lab for a long time, and I'll show you the timeline here in a second. But that lab grew over time. And I started small, and I built it to help further my personal and professional career. And that goes back all the way to 2003 when I was in college. My first home lab was a single old PC running Windows Server and just trying things out. And over time, as technology evolved and as my skill set and needs evolved, my lab has grown. And every time I hit what I would consider a career highlight, my lab played a role in it. Either helping, with my blog and providing me with the environment that I would use to actually develop and write my content, to helping with my VCDX and testing out my design, to even helping land specific jobs and helping with my job as I've gone forward by giving me a place to test out new things and develop my skills. And my home lab was really essential for all of this because it got me hands-on with the technology and was able to understand how things worked at a deeper level. And when you start getting into things like blogging and presenting at VMUG, it's really hard to share information. It's really hard to share what you learn if you don't have a place to test it out. And what this really comes down to is your home lab is an investment. Now, there's many types of investments here, right? They're first and foremost an investment in yourself, in your skill set. You're taking the time to develop yourself and build new skills. But they're also an investment in other areas. There's a financial aspect to it. There's a space aspect to it. You have to have a place to store it. And there's things that come along with that, like power and cooling and all those things that we talk about in a lot of those more, practical home lab sessions. And then there's a huge investment in time. And it's not just time in building the lab, but it's time in using the lab and actually getting things out of it. So the premise of this presentation is, how do you make the most of that home lab investment, right? You don't want that lab to be an expensive pile of silicon sitting in the corner of your basement, heating it during the winter, right? And all too often, that's what it seems like they are. And in all honesty, there was about a year where my home lab was exactly that, mostly, right? It heated my garage in the winter, and in Wisconsin, there's value in that. Right? We get cold winters, but it's not the most efficient use of that hardware. So to really drive the value out of our labs, we have to put on our architect hats. And what I mean by that is we have to start looking at outcomes, right? Everything that we do in IT, whether it's in our career development or in what our business is asking for, should be driven by our outcome. And what that means is asking the question, what do I want to accomplish with this? What do I want to learn? And that turns into, what is our use case? So in particular, in my home lab, I have 5 main use cases. Well, 4 for me and one for a few others, right? And these are all things that I wanted to learn, or things that I wanted to experiment, and I had outcomes that came along with it. So like one of the things up here is learning advanced routing and networking concepts. When I joined VMware, I joined as an EUC guy. I couldn't spell NSX or BGP, right? I had no concept to it, and if somebody asked me how NSX worked, I'd just say it's magic, which is, by the way, technically true, but it's, when you get up in front of a customer or partner, saying something is magic, Clark's third law doesn't work there very well. So I made a plan to learn those technologies. I found ways not only just to learn them, but to implement them in my home lab so that I was getting practical experience out of it. I was tying it back to use cases that some of the partners and customers that I worked with were talking about, but finding ways to implement it that had value to me. So when it comes to things like self-hosting or open source projects, right? Cut down the cloud bills, be a little bit more sovereign cloud-like in managing my family's data, kind of maintaining my privacy. That tied a lot into the advanced networking because those were things that the partners I was working with was asking about. And so trying to find ways to tie what I was doing at work to my learning, enabled me to do a little bit more and drive a little value out of my lab. Of course, there's this last one here too of, my kids want lots of Minecraft servers, being able to, tie, networking to that. So they, isolate their Minecraft servers, let them have their friends connect to them, right? It was another way for me to learn those concepts. So what it comes down to is having a plan. Now, in my case, the plan wasn't nuking the 12 colonies of COBOL, but it was putting together things that allowed me to build my skill set. And to start with that, I actually had to take stock of what I had. When it came to learning advanced networking concepts, right, I had to understand where my skill set was. My CCNA had expired in 2013 and a lot had changed. And CCNAs don't cover BGP. So I had to go through and figure out what I needed to learn and then figure out how I needed to shift my lab around to be able to take advantage of that technology. So it's not just taking stock of what you have, though, from a skill set a skill set wise, it's also taking stock of what you actually have on hand. Will your hardware, fit your needs? Will your space fit your needs? Does this fit your use case? And if not, what do you need to do to make your use case work? And time, right? We're all busy. Maybe it's family stuff, maybe it's community involvement, maybe it's all of the above, right? But you have to take away something in order to invest in your skill set. So how long do you think it will take to develop those skills? Do you think you can accomplish it in the time you have? And if not, what do you have to take away from in order to do it? And that's a key consideration here as you go forward and utilize your lab. And you can't just try to jump right to the end state, right? You have to think about prerequisites. You have to think about intermediate steps. And while it is fun to just try to deploy something and see what breaks, because you can learn a lot from that. And God knows I have learned a ton by just trying to go, oh, I'm gonna do this, and this is where I need to be. Forget everything else along the way. I'll just figure it out. You aren't necessarily making the best use of your time there. And finally, you need to get the required approvals. Now, in our enterprises and work environments, that's usually IT managers, change advisory boards, budgeting processes, etc. You still need to get these kinds of things done at home, and we have the spouse acceptance factor, right? All those expenses that we have to put in, whether it's financial or time related or space related, are things that we need to sign off on because they do impact they do impact our family. These are things that need to be discussed. If you want to invest a lot of time in learning a new technology, and you also have kids to get to scouts and soccer and get to and from school, as well as try to fit a 40-hour work week in there, something's got to give. And those are the conversations you have to have in order to actually be able to dedicate time to your self-development and self-learning. And lab projects can die on a vine because life gets in the way. And sometimes you do have to set those aside. So you have to find a way to balance your career development with everything else going on in life, including your day job and family. So I know this session was scheduled for a half hour, but I think I'm going to give Alistair about 15 minutes back because I'm basically up to the end here. My final takeaway is you have to ask yourself, what do I want to get out of it, right? I'm going to make this investment in my lab. What do I want out of it? And how am I going to get there? Because that's the only way you're really going to be able to get that value out of your lab and out of the investment you make. And in the end, how you're going to really make an investment in yourself. So I want to thank everyone for coming today. If you haven't had lunch already, you get an extra 15 minutes back to go get in line, and hopefully they have some really good food down there today. So thank you. If you have questions, I'll be off to the side here, and have a great day.
Thank you.
You're welcome.
This season has been great.
All right, hey guys, my name is Tristan. I think we've already been introduced, but I'm based in Portland, Oregon. I'm a field solution architect with Pure Storage, but I'm also a vExpert, and I run the VM user group in Portland, Oregon, where I live. So I always like to submit session ideas for VMware Explore, and sometimes I come up with an idea, a concept, a project that isn't built yet, but I build it between the time that I schedule my flights and I arrive here in Vegas. So what I did was I came up with a very simple Power CLI based method to rather elegantly provide a very simple user interface to assign SPBM policies, vVols policies based on virtual machine tag. So what I'll do is I'll walk through kind of the ideation. I'll do a level set on vVols for people that are not familiar with vVols, and then I'll show you the script in action. So virtual volumes really are a well-orchestrated architecture similar to RDMs, but with a policy engine in vCenter that help tie everything together. There's a lot of performance and capacity benefits of virtual volumes, but one of the biggest benefits is just the built-in policy administration, where you can advertise capabilities, advertise policies, and assign those policies based on very simple rule sets that are enforced by the policy engine within vCenter. So the SPBM policy engine lives within vCenter, and it's actually interacting with the registered VASA providers to not only search for advertised services, but then actually place workloads and enforce placement of workloads on the appropriate storage with the appropriate set of capabilities based on what you configure. I've got a peer array listed there, but this will work with any vVols storage platform. So the reason to target with tags really is it's sometimes difficult in a large environment to right-click a folder of VMs, assign a machine policy, assign a replication policy en masse. Sometimes it's easier to do it as code, especially if you're new to vVols and you want to take hundreds of VMs and assign policies consistently. You might have a gold service tag, or you might have a service tag that describes the production status of a workload already. Or you might have something in your CMDB that you can port over as a virtual machine tag, and then you could use that for the basis of the targeting. This is a consistent, easy way to move to vVols in production. You can go with a no vVols policy. You can actually operate vVols with no storage policy whatsoever. That's called a no vVols policy. But what most customers do is they create kind of a three-tier approach, tier 0, tier 1, tier 2, or maybe a gold, silver, bronze, that dictates how often we snapshot, how often we replicate. Maybe we set a quality of service upper limit at the vDisk level. Because normally a quality of service, at least with Pure, we set at the data store level. If we could do that at the disk level, it actually gives us a little bit of performance fencing. Make sure that we don't have a noisy neighbor overrun a particular array. Tags are kind of a way that you can manage lots of different things, including SPBM policy. So I talk to customers about building a tagging taxonomy. What does the tag associate, or what is the tag associated with? Does gold mean higher availability, higher performance, encryption or non-encryption? So all these services you can tie conceptually to that, that tagging construct. I believe in storyboarding. Before I automate, before I actually sit down at a keyboard, at a console. And so this is kind of the ideation of my particular approach in breaking this problem down. I want a PowerShell, basically script to log me into vCenter, present a list of production tags, possibly list a couple of VMs that are assigned that tag, and then based on a user interaction, actually apply a particular tag to those VMs. So very simple UI, very rudimentary. And I gave an automation talk earlier this week where I talked about how I storyboard and how I come up with these ideas. I could have used something other than PowerPoint to come up with this method. In this case, I just came up with a very simple flow diagram of this is what I want to build in PowerShell. The next process, I don't really have a slide for, but I go out and I find script libraries where I have code segments that do the individual things that I need done, like the commonly executed connect to a VI server, or get virtual machine tag. I go steal all y'all's code, and I take some of the good stuff, and I add it to my code. And sometimes I take out the bad stuff, and sometimes I even go on GitHub and provide a comment, and I say, hey, I've seen a flaw with some of your code. So let me shut the slides down here. If anybody goes through PowerPoint withdrawals, please let me know. This code I will put out on GitHub, and if you contact me after the talk, I'll actually map things out. But a very simple connect interactively, entering the password, not storing the password in the script in plain text or encrypted. I connect to vCenter, I go out and I get virtual machine objects that have a particular tag, I create an array, and then I loop through the array applying policy. And the policy is governing the snapshot schedule and the replication schedule. Very, very simple mechanics. And here's the script in action. So you can always spot a peer customer or a peer environment because there's usually a giant orange logo there at the bottom in plugins. So we'll hopefully have this script render. I think that's running. Oh my goodness, I'm not sure what's going on with my... Wow, talk about a failure to launch. There we go. So here's my Vegas Baby folder. I got some production VMs. They happen to have some tags assigned to them. I could right click and assign a policy in the UI here, but we've got a service tag. We've got an SBBM policy that is kind of aligned with the service tag by name, in this case, gold. So here's my policies. Search for gold. You can see I have a lot of gold policies in my demo environment. I have 18 systems and lots of demos that I run here every day. Here's all the policies that I'm getting, my snapshot schedule, my replication target. I could be fanning out my replicated VMs out to multiple sites for data protection purposes. The script logs into vCenter. I don't want you guys to see my username or password, obviously. So I'm connected to my lab. I provide the user a choice. Do you want to do gold, silver, or bronze? In this case, I choose the gold policy. It goes out and finds the machine tags with that name, gives me a list. And then it basically executes the policy assignment, and then it wraps up. It's simple, it's dumb, but it's elegant. And at scale, this could be applied to not 4 servers, but it could be 400 or 4,000 servers. So this, to me, is a time saver. Notice that the data disks and the config disks are all being targeted. Because remember, these are simple VMs. They have one virtual disk and one config vvol, and both of those are getting the same policy. I could make this script a little bit more complicated and provide a different policy for the config vvol and the data vvol, or I could apply a different policy to all the individual disks. So your mileage may vary, may cause dry mouth. Please stay hydrated. Anyway, policies applied. If we actually go onto the peer array on the back end, we can verify that all the vvols, individual vvols and the volume groups are applied the tag. That is pretty much it. That is my demo. Are there any questions? I think I'm right at time. Pretty close. Any questions? Right. Yeah. Absolutely. So at least in Pure, every vvol is a volume, right? And this is true of any storage platform. A volume is a volume is a volume. A vvol is no different than a data store, or I guess you could say it's analogous to a LUN. An entire LUN dedicated to that one virtual disk. That sounds terrifying, right? Sounds like you're gonna, what I say, herding kittens? It's very difficult to get your brain around. The SBBM policy engine is what organizes all that chaos and makes sure that all of the data services policies are provided consistently and enforced. If you actually go out and look at an array and look at all the vvols individually, you'll pull your hair out, trust me. Because the sheer number of all of those vvols, it'll scare you to death. At least at my company, we don't care how many volumes you put on a Pure array. We don't care. But the policy engine within vCenter really keeps things tight. The other thing that's really cool is, at least in our plugin, when you build a SBBM policy, our plugin actually builds the data protection policy, so the snapshot schedule, the replication schedule, can be built as you build the SBBM policy. So that way your back-end data policy, your Pure policy, lines up consistently every single time with your VMware policy. And Steve, the admin, doesn't have to call Susan the VI admin and say, I created a protection group on these volumes, go ahead and create your, it's a one-step, one shot, one kill process. So, and the question there was, I think, around, right. Right. Oh yeah, of course. Yeah, so we always have a default data protection policy on every array that dictates kind of the default snapshot policy. So we're always snapshotting. But what you can do is you could actually assign a default policy in a vVol's data store if you wanted to. If you so choose, you can have a default policy that gets assigned every time. I choose not to because I always want to have a kind of a customized, I want to have intent around the policy that I sign. And I think that's a good practice. So really appreciate your time. Thank you for coming. I hope everybody gets home safe from Vegas. And if you're staying over the weekend, I hope you win lots of money and eat good food. Thank you.
Good afternoon. Welcome to this VMTN Tech Talk. We are going to talk about how to fast track the application development using AI ML tools. And this is a suggestion that we are going to give. And right, you can utilize these suggestions for your fast tracking application. So this is a standard disclaimer that we show at every presentation. I will pause for a few seconds just for you to glance it. Okay, so let's introduce. Right, so my name is Mukund. I am part of VMware IT. Close to 11 years in VMware, and 26 years in the IT, managing something called modern application platform in the IT side. And along with me, I have Scott. Scott, you want to introduce yourself?
Yeah, my name is Scott Tilney. I'm a software engineer on the emerging technologies team at VMware.
Okay, thank you. Thanks, Scott. So this is the high-level agenda, right? We'll look at what are the high-level platforms that a developer will be utilizing, what are the full-stack tool stacks that our developers are using, right? We'll understand the new concept, that is the ML ops, which is going to be predominantly used by all the IT people in the future. And in this case, we will be also looking at Kubeflow and the OpenCV, right? These are the high-level agenda points that we will be discussing. So let's start with the scale of operation that we have at VMware IT. Right? So on the screen, you will see the number of, you can say, the high level of operation that we have at VMware IT. Particularly, I would like to highlight two things, right? The number of VMs that we are creating and destroying on a weekly basis, and the number of containers that we are creating and destroying on a weekly basis, right? So you can see that 1.5 million, that includes the R&D workloads as well, and the 3.1 million containers that we are creating and destroying on a weekly basis. This also includes the R&D. So this is the high-level scale of operation that we have. This includes the IT workloads as well. Right? Okay. So as I mentioned earlier, right, we'll be looking at the platforms that a developer will be using, or generally will be using. We'll look at the collaboration tools that a developer needs to effectively collaborate with other developers. We'll look at the dev utilities and tools that generally IT developer is utilizing. The next two things are, you can say, soft skills of a developer, which we'll not be discussing in this topic, and also the main driving factor for any application development is the company priorities. So unless and until you have clear company priorities, it is very difficult for anybody to start coding and start developing any applications. Okay, so with this, let's look at the platform side. In VMware IT side, we have divided the platforms into in generic 4 pillars, sub-pillars. One is the underneath infrastructure, wherein we are using Kubernetes-based platform, PCF and TKG is the foundation. Then for the CI/CD, we realize automation is used. We realize code stream is also used. On the code security side, various tools are used. I have depicted two things. One is what is used in VMware IT, as well as the open source, which is equivalent, we can use. And then, of course, last but not least, the monitoring side. After this, as a full stack developer, what are the tools that the developer is generally utilizing, and we also listed out open source tools which a developer can utilize. So this is traditionally for your all application development, which is as of now happening. In future, all the developer have to also now look at AI ML related workloads. So in near future, or already, you might see that ML ops become the primary driving factor for all the IT related workloads. So in this, this is the high level picture, I have depicted, starting with your data, ML, how the apps are getting used or getting developed by using the ML programs, and the operation side of it. So this is going to be, you can say, the new buzzword in the market, and then there are various tools which are which can be used for the ML ops. So for this, let me hand it over to Scott so that he can take it forward.
Thank you, Mukund. So as I mentioned earlier, I'm Scott Tilney. I'm a software engineer on the emerging technologies team at VMware. Today I'm going to talk about 3 open source machine learning technologies that you could use to accelerate your application development. So as you all know, the adoption of cloud native technologies using Kubernetes has accelerated rapidly across enterprise. Machine learning and data science has also accelerated across enterprise as well. The problem is a lot of teams lack the skills, software, tools, and machine learning operations methodology needed in order to bring your machine learning models into production. It's difficult to have your data scientists become Kubernetes experts, and it's difficult for your Kubernetes experts to become data scientists. So at the intersection of Kubernetes and machine learning is Kubeflow. Kubeflow is an open source machine learning platform for data science and machine learning operations. Kubeflow is not a single piece of software, rather it's many services that come together to create this platform running on Kubernetes. Of course, the advantage of running on Kubernetes is you can run it on any public or private cloud. It's portable, so you write once and reproduce everywhere. And if you're used to working with machine learning, you're used to working with a lot of different services that need to interact with each other. This is a perfect use case for microservices. With Kubernetes, of course, you get the advantage of scaling, so you can scale up quickly for the more compute-intensive tasks, such as training, and scale down for the less intensive tasks, such as inference. Kubeflow supports both GPUs and TPUs, so if your Kubernetes cluster is installed on has access to nodes with GPUs and TPUs installed on them, you'll be able to leverage those, greatly improving the time it takes to train your models and increasing performance during inference as well. Kubeflow has a centralized dashboard where you can run and build your models using Jupyter notebooks, and you can use GPUs and TPUs if you have them available as well. You can manage your Kubeflow pipelines through this dashboard, build and deploy your machine learning workflows based on Docker containers, and you could manage and automate your hyperparameters using Katib. So I encourage you all to take a look at Kubeflow. It could really help you streamline your machine learning development, deployment, manage your workflows, and this is really a great opportunity to embrace the future of machine learning operations as well. Now, I understand not every company or team will have access to data scientists and machine learning experts in order to build these models into your applications. But it doesn't mean those teams should be left behind. The fact of the matter is there's also a lot of open source tools and software that you could use and integrate machine learning models into your applications without having to hire machine learning domain experts. And I'm going to talk about 2 of those now. The first one is OpenCV. OpenCV is a powerful open source library for computer vision and image processing tasks. It has a simplified implementation. It provides a vast array of pre-built functions and algorithms for object detection and recognition, facial detection and facial recognition in both video and images. With OpenCV, you could do rapid prototyping. So developers can quickly create prototypes and proofs of concepts, enabling fast iteration and refinement. It's a cost-effective solution. Since you don't need to have the domain expertise in machine learning, you could save a lot of money in recruiting and training while still being able to incorporate machine learning, computer vision into your applications. There are many diverse use cases where you could use this technology. So for example, in automotive, you could think pedestrian detection or driver assistance systems. In healthcare, you could think object detection in X-rays or MRIs. E-commerce and retail, you could easily build a barcode scanner into a mobile application, or do item search and recognition in a mobile application as well. The really great thing about OpenCV is the cross-platform support. So you could write in Java, C++, Python, and you could run it on Mac OS, Windows, Linux. So even if you just have one developer on your team, you likely have somebody who will be able to integrate with this technology. So I encourage you all to explore OpenCV and try to find use cases where you could incorporate computer vision into your applications. The next technology I want to talk about is Rasa. Rasa is a leading open conversational AI platform for building chatbots. With Rasa, you could also do rapid prototyping. It's very easy for developers to quickly build conversational chatbots and applications where you could very quickly iterate on your ideas. The thing that I personally loved about Rasa as a developer is the low to no code approach. The reason this is so great is even a subject matter expert could train the models using Rasa. This frees up a lot of the developers' time from having to spend time on training and tuning the models, and the developers can now focus their energy on building the applications that integrate with Rasa rather than spending a lot of time training and tuning models. Some real-world use cases where we've used Rasa at VMware is to improve colleague experience. So we built an application called Genie, which was a colleague assistant chatbot at VMware. We were able to do things like book conference rooms for colleagues. You could schedule a meeting with a colleague with Rasa. You could check what's on the lunch menu at our campus cafeteria. And you could look up colleague contact information as well. Some other real-world use cases where you could use this software is in customer support. So for example, you could improve response times and enhance customer experience. Sales and marketing, you could do lead generation and product recommendations. And that's something we did at VMware as well. We built a SKU advisor for our sales colleagues so they could recommend SKUs quickly and easily to our customers. You could also do internal automation with like HR inquiries and IT support. And that's another area where we used Rasa at VMware as well. We built a chatbot that could answer IT questions for our colleagues. And this did two things for us. One, it created a better experience for our colleagues. They were able to get answers to their questions a lot more quickly. And two, it freed up a lot of time for our tech support as well. They didn't have to keep on answering some of these more common questions. Instead, we're able to have a bot answer these questions instead. So I encourage you all to take a look at Rasa. It's very simple to integrate with this software. And again, even a subject matter expert, somebody who does not have an engineering background, could build a bot using Rasa. So I know that was a lot to cover really quickly. If you have any more questions regarding this presentation, you could scan this QR code and contact our VMware on VMware team. They could help set up a session where we could do a deeper dive into anything we covered today. Thank you.
Okay, thank you. No, I mean, we're done. I mean, any questions? We're good.
Hey, hello everybody. Welcome to the last day of our conference. Really glad to be here. Been working busy this week. Like this is my sixth session this week. So talking about VMware Cloud on AWS, right? So my name is Caio Oliveira. I'm a principal multi-cloud architect working in the global multi-cloud and architecture and strategy team. But before, my previous role was actually a VMware Cloud on AWS for the Latin region, right? So talking about today, what is VMware Cloud on AWS, right? So this is a jointly engineered solution between VMware and AWS, right? Where we deploy our current stack, also our SDDC, our VCF, on top of the AWS infrastructure, right? So the same components that you're used to have in your data center, vSphere, vSAN, NSX, and vCenter, are now hosted on top of bare metal AWS hosts. The benefits of that is you can migrate, you have different use cases that I will cover in a few slides, but all those workloads that will be hosted there will now have the ability to leverage AWS native services as well, right? So you will be able to connect your current data center or migrate, whatever you want to do, and have also the capabilities of native AWS. This service is available in the majority, like I would say like more than 90% of AWS regions. So this was the first VMware Cloud offering, right? So the SDDC on top of our hyperscalers, right? So back like 2019, if I'm not wrong. So all regions here, so we have a upcoming region in Cape Town, and we have a planned to the Bahrain region, right? So how is that for you, right? What will be your responsibility as customers and partners leverage using the solution, and what will be VMware and AWS responsibilities? Everything related to hardware, the physical infrastructure, how the connections are tied, everything will be by VMware and AWS. So you don't need to take care of that, right? On top of that, we have our SDDC stack, right? So our software-defined data center composing by vSphere, vSAN, and NSX, and a few other components that you could also have some add-ons. All the lifecycle management of those services will be by VMware, so you don't need to think about that. The only thing that will be your responsibility will be what you do best. Your applications, installing the operation system, thinking about the firewall rules, what are the VPNs, the connectivity between this environment and your data center. If you're going to leverage like a direct connectivity, we have the integration with AWS Direct Connect, or if you want to leverage a VPN over the internet, right? And of course, all your data will be your responsibility as well. So very straightforward solution. At the moment, we have 3 different host types available. So we have i3, i3n, and i4i. Pretty much those will differ based on the amount of RAM that you need, and also some of the CPUs. So some have more logical cores than the others, as well the storage. I think the storage piece is the one that differs the most. So depending on how much data you're gonna need, how much storage you're gonna need, will differ from one another. What is good is that we have a sizing tool that's available, it's open for you. So you have the link here that you can use and check what are the different ones, and also do a cost analysis to would be the best one. Of course, I always recommend to reach out to your VMware representative, and we have a big team of VMware Cloud and AWS specialists that can help as well to identify which will be the best compute for you. Regarding the configuration maximums, right, you can have more than one SDDC, right? We have a soft limit per organization, that's 2, but this can be increased, right? And also inside those SDDCs, you have a soft limit of 10 clusters per SDDC, right? So this is really interesting. Depending on the if you wanna segregate your environment, you can create different SDDCs. You can have one big SDDC, and you have also a way to connect those SDDCs together, right? The minimum for a production environment to get a full SLA is 2 hosts, but we also have one host option. That's more for testing purpose, no SLAs, so be aware of that. And inside this, you have the management cluster that will have vCenter, NSX Manager, all the edges and all the add-on components as well. As I mentioned, you don't have to think about anything related to the physical infrastructure. So if you have a problem, for example, we identify a problem in a specific hardware, we're gonna add a new host to the cluster. We're gonna evacuate, so we're gonna resync all the data for that new host, and we're gonna remove the host that have a problem. The only thing that you're gonna receive is an email saying that we identified this host, we are adding a new host, and now it's remediated, right? So everything related, as I mentioned, to the lifecycle management of the host will be done by VMware and AWS. You also have the possibility, when you have in your organization, to have a cluster or a stretched cluster, right? When you create one cluster, you are tied to a specific availability zone, right? So you're gonna have 99.9 availability guaranteed, but if that entire AZ have a problem, for example, you might lose your environment. So for really high critical applications, we definitely recommend for you to have a stretched cluster. So all the data will be synced between 2 different AZs, and you have also one AZ that we're gonna host like a different from those 2 availability zone 1 and 2. A third one we're gonna host the vCenter witness node for in case of any problem with one of the regions, right? So here also a great solution that we developed since the beginning. So for you to get started, there's really easy. There's a lot of onboarding on the platform. Really easy for you to create the SDDC. You have only to fill a few information, connect to your AWS account, and pretty much you can create your SDDC. It takes about 1.5 hours, 2 hours for you to have a fully deployed SDDC ready to go. Which also really interesting if you're using any Microsoft, so SQL or Microsoft Service, you have a way to have the integrated licensing inside the portal. So you can leverage that as well inside. So you don't need to think about and have like an extra burden to manage all your licensing. That's really interesting, and this is activated per cluster. You can have a cluster that has the capability and another that doesn't. Moving forward regarding the connectivity piece, so the networking piece, everything is powered by NSX. So all the capabilities, everything that we have with NSX is provided here, right? So there's multiple interconnectivity options. You can, as I mentioned, leverage internet. You can create a VPN to your on-premise environment. You can leverage AWS Direct Connect is a way for you to have a direct connectivity, right? And also you can leverage HCX to migrate the workloads, right? And HCX can run on top of the internet or on top of the private, the Direct Connect. Recently, not so recently, I think there's about like 2 years ago, we introduced also the VMware Transit Connect, where you have a lot of other benefits. You can connect this SDDC, this environment, with any of your VPCs. VPCs, for people that don't know, is the network construct inside AWS. So if you have native services running in different VPCs, there's a way for you to connect those to the SDDC. As well, we leverage the VTC if you want to have connectivity between 2 different SDDCs in the same region. We have as an add-on as well the NSX Advanced Firewall, right? When you're gonna have as layer 7 distributed firewall, identity firewall, as well distributed IDS and EPS, right? So if you want to leverage that, that's paid as an add-on, is not included in the basic SDDC. On the other hand, HCX is included with the SDDC, right? So I would say like 60 to 70% of the primary use case we see with VMware Cloud and AWS is migration. And for migration, HCX is the tool to go, right? So you can connect, you have a HCX connector that will integrate with your on-prem vCenter, and also HCX Cloud that's connected to the SDDC on the vCenter on the SDDC on VMware Cloud and AWS, right? So it's a really easy way for you to migrate your workloads to the cloud. What is good as well, we have integrated Tanzu services, right? So we have Kubernetes Grid, Tanzu Kubernetes Grid, so TKG as a managed or a non-managed service, right? So this is one of the benefits and one, I think, AWS, VMC in the moment that has this capability that you can let VMware manage the entire Tanzu Kubernetes Grid for you, or if you want to manage it yourself, you can as well, right? So let's just move on. So this is pretty much what I had to cover today. That was a quick session. I hope that could provide a good summary for you. There's a lot of a ton of content, not only here, there will be a lot of recordings for all the sessions today, but TechZone is definitely the single point that you should go to get all information related to AWS, right? So hope you enjoyed the session. Thank you for your time today. Bye.
Welcome back, everybody, to the VMTN Community Theater. Thank you for joining me for one of the last sessions of the vBrownBag Tech Talks here at VMware Explore in Las Vegas. I am Tony Foster, and thank you for joining me for the SEO strategies for my community blog that gave me six-pack abs. Obviously, I do not have six-pack abs, and we will address that here in just a moment. I am Tony Foster. I am a technical marketing engineer at Dell. I do a lot of blogging both personally and professionally. I am also an adjunct professor at K-State in Kansas, so I have fun teaching as well. Now, we've got a lot to cover because SEO is a huge topic, and we're going to hopefully give everybody the start of a recipe for six-pack abs with SEO. So, the impetus for this entire presentation actually came from Explore last year. I was actually participating in the hallway track, and John White and I were talking outside of the community theater, and he's like, you have all of these great tips. You need to write it up in a blog. You actually need to do a session on this. So I'm doing a session, and the reason I chose six-pack abs is actually from a song by Brad Paisley called Online. And I have some of the lyrics here, and you'll notice that the very last lyric, and I've got a set of six-pack abs that would blow your mind. And this is all about online. Online, you can create your own persona. You can be whatever you want to be. So I am the Wonder Nerd. I obviously don't have a set of six-pack abs, but I got you to come with that. So you came here, you joined me, and you're actually getting to see how I do all of this magic. So let's talk a little bit about what is SEO and why it matters. SEO, for those who don't know, is search engine optimization. And basically, out on the internet, you have these wonderful search engines, Google, Bing, you name it. There are search engines out there. And if we want to have our site, our blogs, our whatever, rank higher in the search results, we need to appeal to those search engines. And they send out little spiders that go through looking for different pieces of information. And we're going to talk about those pieces of information today as we go. And it's all about making your sites look good to those search engines. You want those search engines to like you. So for example, on this screenshot, you'll see when I search Wonder Nerd, I have the top result returned back on Google. So in fact, I have the top 4. And if you look at the number, that's about 0.04% that we're talking about. So it's pretty cool to be able to pinpoint that close. And that's what search engine optimization helps you do. So what's the first thing you need to do to really empower your search engines? Well, you want to start out with a good title and headings. They make things look good. They start to define those six-pack abs. And the title is the most important thing. It's not only the first thing that you, when you search, see, it is also one of the first things that the internet spiders that crawl the web for the search engine see. And so they're going to look for that. And they're going to find that and pull that in as part of their algorithm to see what's going on. The other part are headings. Headings help separate things up and help split information out for the spiders as they crawl. So they can see what sections are of interest. And if you look at this Bing result here, I did a search on what is VDI by day, compute by night, and cycle harvesting, and it actually gives me a definition of it. It went into the middle of my blog and pulled that out. And headings help it to be able to actually do that and go in and find those locations. So that is another important element When you're blogging, you want to create titles that catch people's attention, and you want to create headings so that you can jump to the right spots in the blog as you go along. Now, let's flex some SEO muscle here. Content is actually king. All of these spiders are really advanced in what they do. They're not just sitting there going, oh, it's a blog about AI or GPUs or anything else. They're actually sitting there looking at the content, looking at the flow, making sure everything is logical. So one of the things that you want to do on your very first paragraph is make sure that your title flows right into the first paragraph. In fact, your first paragraph traditionally should contain all of the words that your title has. Doesn't have to contain them in order, but they should all be there because the spiders and the search engine systems all sit there and look at the words and go, does the title actually match with what's going on in the body of the text? So you want to be sure to include those and have that logical flow from A to B to C. If you don't, the search engines are actually going to demote your score. So it's important to make sure you have those links as you go. And again, it ties back to the headings. Your headings should do the same thing. First paragraph following a heading should have the content from the heading as well. Now, links and pictures or it didn't happen. You gotta have links and pictures. I mentioned earlier that the spiders that crawl the web are very, very intelligent. And in fact, the spiders that crawl the web look at your pictures and see if everything jives, if everything matches up. It's going, does this support the content that's supposedly on this page? And if you look at this picture, I don't know how many people here have actually seen websites and search results before where you'd get a picture back and then a bunch of random text underneath it with stuff that makes absolutely no sense. So we have a license plate here in this picture and then a bunch of random stuff underneath there. And before, this is what was called gaming the spiders. They'd sit there and put a picture in that they wanted you to actually look at. Normally it was very inappropriate. And then they'd load it up with all sorts of random stuff that doesn't apply. And the spiders got smart to this about 10 years ago and were like, nope, this stuff doesn't match up. So you want to make sure your pictures and your content all match in there. Now, that said, I will say sex sells, and it does sell very, very well. And it doesn't have to be overtly sexual. But when you can sit there and make something sexual or controversial or outlandish or use power words, you're going to increase your hit rate. It gets people's attention. So the title of this section is about my six-pack abs from blogging. Hopefully that drew some of you into the theater. I went for something completely crazy to try and draw you into the theater. And you can do the same with your blogs. If you use those power words, if you use stuff that seems crazy like, I'm gonna do a deep dive on this, or you don't know what you're talking about, you're going to get more readers. You're going to trigger SEO spiders to be really, really interested in what you have to say. Now, that said, you also wanna apply the KISS principle. Keep it simple, silly. Spiders like it when you keep it simple. If you make it too complex for the spiders, you've probably also made it too complex for your audience. And of course, we've all seen this meme, change my mind. That is a great way to approach writing your titles and your content. Change my mind. Why are you interested in this? What am I saying that's wrong? So that is a great thing to do. Now, one of the things that you will find in a lot of systems are meta keywords. Meta keywords aren't actually used a whole lot in the SEO system anymore. They've actually demoted the importance of keywords. However, keywords are still important in most blogging systems. WordPress will actually work with keywords to index your pages and stuff and show relevant content at the bottom of your blog post if you have that feature turned on. So the keywords still do play an important role there, and you do want to put them in. Now, don't game the spiders. Don't try and game the spiders. I showed you an example before with the license plate and everything. Spiders don't like being gamed. If you game a spider or try and game the spiders, they will figure it out that you're trying to game them. So don't create a bunch of different websites and link all your pages there and cross-link it and everything and try and increase your search results because you have a lot of different links going out and into it. Spiders are going to figure that out, that you're just playing them, and they're going to lower your search ranking. You're going to be lower down on that Google results list. So you have to be honest about what you're creating. You can't sit there and put something up that is completely bogus just to draw people in. And if you're really bad about it, search engines may not even show you as a result. So they can actually do that. It's their system, so more power to them. Oh, went too far. So we're going to get this lined up for a finish here. There are lots of tools out there, giant tools out there. Most people for their blogs use WordPress. I've seen numbers that anywhere between 40 and 90% of websites on the internet today use WordPress. And the SEO tools available for WordPress make life so much easier. They provide you real-time feedback and automate the insertion of a lot of the metadata and stuff that SEO engines look at. Here we have an example of all-in-one SEO, which is one of the two that I like. I use Yoast and all-in-one SEO on my websites. You can see here in this screenshot, I've got a score of 60 out of 100 on this potential title because I tweaked my keywords and everything. And I can continue tweaking all of these keywords to make the title more appealing. And then I can go through and see the same results as I go through and write the paragraphs and everything to make sure that I'm including all the content that these guys actually work on a daily basis for SEO. Now, your own six-pack. We've gone over all of this so that you can create your own six-pack. Good titles and heading, match the content, be edgy, pick your keywords wisely, and don't game the spiders. That said, thank you for attending. If you have questions, I'll be over here on the side, and we hope you enjoyed this vBrownBag Tech Talk.
Hello, welcome everybody. I'm Caio Oliveira, based in São Paulo, Brazil. I'm a principal multi-cloud architecture at VMware. I work at the global multi-cloud architecture and strategy team. And this is my 7th session this week. So really tired, but really excited as well because Google Cloud VMware Engine is actually one of my preferred topics, right? So my day-to-day job is pretty much walk and help customers and partners on their multi-cloud journey. And we are seeing a lot of increase about Google Cloud VMware Engine. What is VMware Cloud, what's Google Cloud VMware Engine? This was based on the partnership between Google and VMware, right? So the same way that you have VMware technology on top of your servers on your data center, now you have the capability to leverage the Google hardware and put the infrastructure on top. Everything is integrated inside Google Cloud Platform, and I will highlight a few of the main features. This is a really high-level session. I only have 15 minutes, but there's a lot of content over there about this technology. So what the key strengths that we see when we talk about Google, right? I think resilient network, we don't even need to mention. I think everyone here at least uses Maps or Gmail, everything. So everything is based on top of great technology that Google developed, right? So a lot of like business transformation, analytics, everything is environmentally friendly. So a lot of great features and strengths regarding the Google Cloud Platform, right? And what are the now putting like VMware on top of this great technology, right? You have a way to get your applications, to get your workloads and migrate it to the cloud, right? Good thing is that you're gonna have the same technology. So when you deploy a Google Cloud VMware Engine, you deploy an SDDC on top of Google Cloud Platform. So the well-beloved vCenter, vSphere, NSX, and vSAN will also be there. So all the skills that your team already have on VMware technology, you're gonna be leveraging that on Google Cloud Platform, right? So as I mentioned here, imagine that you have your current on-premise environment. You need only to have vSphere, but of course you can have NSX or the vSAN, and you have a way to connect that with different options that I will explore in a few slides, and have your SDDC on top of the Google Global Infrastructure, right? So you're gonna have an SDDC. In Google's terminology, what they call is a private cloud, so a VMware private cloud, when you're gonna have vSphere, vSAN, and an NSX. So what's good for people interested in more in pricing structure, VMware has a universal package that you can have credits and use those credits in all of our current offerings. And Google Cloud is also part of the VMware Cloud Universal deal. So if you're more interested in that, search for our VMware business counterpart. That definitely he will explain way better than me. I like the technology piece that I will explain for you. So where Google Cloud VMware Engine is available pretty much in all of Google regions. So in several regions in Americas, in the EMEA as well, APAC, all pretty much the data centers have. There are a few ones that are planned, but I would say like 90% of the Google regions already have Google Cloud VMware Engine available. And what are the main use cases that we see for that solution? I think I would say, in my experience and what we see all over our customers, 60 to 70%, the primary use case is cloud migration, right? So when you have a way to migrate your workloads from your on-prem data center to the cloud. Or as what we say, a data center extension. Imagine that you have a data center and you want to expand, but you want to expand more in a SaaS mode, right? So leveraging the cloud, definitely a big use case. And the other ones are actually really important as well, especially DR is getting increased nowadays, especially when you start moving your workloads to the cloud, or you already have a data center and you're planning to have a disaster recovery solution. So leveraging Google Cloud VMware Engine is really an interesting point on that. And of course, VDI, application modernization, are also good use cases that we're seeing, but not as huge as cloud migration. So talking about the technical details here, right? At the moment, we only have one flavor available, so one hardware specification is what this model is. It's pretty much you have 36 core, 72 as using the hyperthread, 768 gig of RAM, and I would say a lot of networking and storage as well. On the right side, you can see all the software specifications. What are the SDDC stack versions? So we have ESXi, the 7.0 version, vSAN as well, NSX is 3.1.2, and HCX 4.5, the enterprise version, right? So when you deploy an SDDC, right, you have to be a production environment, have to need at least 3 hosts, but you also have a capability to deploy one node to test out the solution. So with on node, all the applications will be deployed in the same host, but if you want an SLA and if you want a production environment, you have to go to at least a 3 node, and you can add more hosts, add more clusters to that environment. Regarding what's the technology that enables all the connectivity? Is NSX here. So every service, so all the L2 to L7 services on NSX are available in the platform, right? And you have different ways to have connectivity between your environment, so your data center, and Google Cloud. You can leverage VPN on top of the Ethernet. You can have some SD-WAN solution, and you also have a way to have a direct connectivity using Google Cloud Interconnect, or even leveraging a partner, right? So it will depend on the use case, but we normally see for production environment customers going towards more a dedicated and private connection leveraging Google Cloud Interconnect. One important point is one of my preferred tools is VMware HCX. HCX is a migration tool, and the enterprise capabilities are included when you deploy an SDDC, when you're paying for a Google Cloud VMware engine. So that tool will help you to extend networks, migrate workloads. When you extend the networks, one of the big issues, can I keep the same IP address that I have in my current environment? And the answer, yes, you can extend a network, you move your workloads to the cloud, and then if you are evacuating your data center, you just break that extension. That works really well, and you can do also not only on-prem to cloud migration, but also cloud to cloud migration. So if you are going towards a more multi-cloud environment, you definitely can leverage HCX for that. Moving forward, that's really important, and everything that's related to the cloud, you have to pay attention which are the cloud responsibilities, so the vendor responsibilities, and what are your responsibilities. Everything related to the infrastructure, the provision of the services, the life cycle of not only the hardware piece, but all the SDDC stacks will be by Google. So Google sell the solution, operate the solution, and maintain the solution. If anything has a problem like related to VMware, it will be Google that will connect to us, right? So that's really important. You have one single point of contact. Everything else, what you do best, what you create your VMs, create your applications, will be your responsibility. So creating firewall rules, creating, like installing the operation system on those VMs will be your responsibilities. And all of our stack, pretty much, not all, but like the majority of our main offerings are also validated and able to integrate with Google Cloud VMware Engine. So VMware ARIA, Horizon Platform, AVI, that's NSX Advanced Load Balancer, Tanzu Kubernetes Grid, our SD-WAN solution, VMware Site Recovery Manager, and also vCDR is also available in Google Cloud VMware Engine, right? I tried to summarize everything here. There's way more to talk about Google Cloud VMware Engine. Unfortunately, this is only a 15-minute session, but if you're interested in more, there will be a lot of info after the Explore. All videos, all sessions will be that are recorded will be available for you. I definitely recommend you to go, and there's a deep dive on a lot of those solutions, right? Appreciate your time today, and hope you enjoyed the conference, and thank you.
Hello, my name is Tristan Todd. I'm a field solution architect with Pure Storage. I'm also a vExpert, vMug leader in Portland, Oregon, where I'm from, and I was a VMware employee for about 10 and a half years in various roles. Now that I work for a storage company, I spend a lot of my time evangelizing our technology that we build at Pure, but also embracing the technology that VMware has introduced into the SDDC solution. So I want to talk a little bit about vVols and a pragmatic approach to vVols adoption. Quick agenda there. We are going to talk about patterns of failure and keys to success towards the end. Then I'll provide a few resources for you as well. So vVols are really a well-orchestrated system of raw device maps. They offer the same performance, the direct access to storage from the host hypervisor passed to the VM, but the vVols are a much more modern way to present raw capacity or raw performance to a host. There is no file system. There's no file system structure with vVols because you're actually presenting volumes, data stores, LUNs as virtual disks to the virtual machine. That means that we can data reduce really efficiently. When you actually delete data on a virtual disk, we can actually delete it for real, freeing up that capacity for other workloads. We don't have to pre-provision storage capacity because a vVol is thin by default. Storage policy-based management is the bulk of what I'll talk about as far as value. The built-in automation in SPBM, storage policy-based management, has been around since 2015. Don't ever complain about the cost of vCenter licenses if you're not using something like SPBM to manage data service policy. It's been available, vVols have been available in vSphere since vSphere 6 was introduced, around 2015 timeframe. Over the years, vVols, the SPBM policy construct, the VASA provider has been developed quite a bit, refined, and made better and better with each vSphere release. And finally, integrated replication management. If your data is important to your users or your business, then having replication management built into the storage stack at the vDisk level is critical. And I'll talk a little bit more about that here in a second. So when you compare VMFS, where we've spent a lot of our time over the last 20 years, to vVols, it's a vastly different approach. I'm not going to really speak to the slides, but I'll just explain one of the biggest challenges that I face with VMFS volumes, large VMFS volumes. If I have a large VMFS volume and I place a lot of virtual machine workloads on that volume, every one of those virtual machines really needs to have the kind of the similar performance requirements, similar, I need to have a handle on what their capacity life cycle is, how big are they going to get, how much storage am I going to have to add over the years. And I have to apply the same security and data protection policies at that data store level, even though it might not be appropriate for some of the individual VM workloads. So if I was able to do the same policy assignments, provide the same data services, more flexibility in capacity forecasting and management, and do it at the vDisk or the VM level, that to me is a big win. Every virtual machine is made up of 4 vVols, 2 at a minimum. A config vVol, which is kind of the DNA of the virtual machine. It's where your VMX files live. For example, every disk is a vDisk vVol. If you use a virtual swap and you actually place that swap file where your VMs live, then you have a vSwap vVol. And if you take a snapshot of a VM and you capture memory state, then you'll have another vVol. So it's 2, maybe 4 at a minimum. Every vDisk is a vVol. So let's talk a little bit about the benefits, and then I'm going to go back to those 4 different types of vVols and tell you why that can be a challenge. This policy that I've got up on the screen is pretty elaborate, but it represents a lot of data service capabilities that are assigned to individual vDisks, and it controls snapshot schedule, quality of service limits, replication target, and workload placement. And I have a simple policy called production gold. I tag any VM or vDisk with that production gold policy, and the SPBM policy orchestrator will check for compliance continuously for the entire life of that VM, which means if my colleague Steve storage vMotions the VM to the wrong storage volume or wrong storage array, it's a policy violation. Steve gets a ServiceNow ticket in his inbox assigned to him, hey, move that thing back, right? You're in violation of the gold policy. And that policy engine doesn't sleep, it doesn't take PTO, it's constantly checking for alignment with best practices. If you have a tier 1 workload or a gold workload and you assign the policy, if you have to promote that VM to a different service level or demote it, you just change the policy and the settings go into effect instantly. And you didn't touch the storage array at all, ever. The second thing that's cool about vVols, we can actually break a VM up and apply individual vVols policies to each of the individual disks. A large Oracle server, you may have a different data protection or performance policy assigned to the OS disk versus the log directory versus the local backup volume. So a lot of our customers, a lot of the people that I work with, have different policies for application servers that have different volumes that are deployed with purpose. vVols are very extensible. You can attach them to anything. It's a data store, okay? It's a LUN, it's a volume, which means we can attach them to other VMs. And on Pure, this is instant. We can attach them to bare metal servers. We can attach them to Azure VMs in native form. We can attach them to Amazon EC2 instances. It is a volume. It is a data store, right? So that's a key concept. It means that vVol snapshots, as long as they're efficient, fast, hopefully metadata-based, you can actually flexibly replicate that snapshotted vVol and attach it to a cloud of your choice effectively. VMware has an excellent white paper, and I think I've got a link at the end of the slide, but it's a paper that compares the performance implications with managed snapshots, VMFS, vSAN, and vVols. And I'll just draw your attention to maybe the performance graph on the bottom. The blue line there represents the performance hit you take when you take a single managed software-based snapshot of a virtual machine. As soon as you snapshot, you use the managed snapshot, the software snapshot that you have in the vSphere interface, you're attaching a boat anchor to your VM. You're attaching a performance boat anchor to your VM. With vVols, there's no change in performance. That green line at the top, that flat line, performance is consistent. The cool thing about vVols, the kind of the built-in hotness of vVols, is when you do a managed snapshot, when you actually go into the vSphere client, right-click a VM and take a managed snapshot, you're actually ordering a hardware-based snapshot to the storage provider. If you run good hardware, good storage hardware, and you should, that should be a very fast snapshot. And if it's metadata bound, it doesn't mean you have just chewed up a bunch more capacity. When you go to delete that snapshot, it's similarly much faster. And you can have as many layers of snapshots as you want, really, until you reach some kind of object limit. So you don't have that 2-day wait to commit a snap or a managed snapshot that you took 2 months ago. You don't have to wait for that thing to effectively get combined in the VMDK level. Anybody ever experienced that pain of the too old snapshot? It's fun, isn't it? I assume everybody has a warning or an alert for snapshots that are too big or snapshots that are too old. All right, awesome. So I'm a data junkie, and I distinguish between the performance and capacity information that vCenter provides us, which is front-end data, right? That is normalized, it's averages of averages the longer the data lives in the vCenter database. I prefer to actually see real-time back-end performance metrics and capacity metrics. So we actually are able to, with vVols, see that information at the virtual disk level. So we can see data reduction benefit on the top right. I've got 2 disks and the parent volume or the config volume, and one of my volumes I'm getting 36-to-1 data reduction. If I come into work tomorrow and that disk is at 10-to-1, right, my overall data reduction for that VM has changed. I can at least see which disk changed, and I can call the app owner and say, hey, what did you do on your D drive? What changed? Did you install an app? Did you double the size of your database overnight? What's going on? Is there a malware event on that particular system? Performance is similarly attractive at a vVols level if you have access to backend performance numbers within the vSphere web client like we're depicting here. We can see throughput, latency, and I/O statistics at a very granular level. Much more accurate data here than what we see at in any of the virtual machine statistics that are fed off of VM tools. So a big barrier, going back to this diagram, a big barrier to vDols adoption for most of us, older geeks is We're used to bucketing our VMs, meaning we create a volume, we create a data store, and we drop some VMs in there. Maybe we call that data store production, or maybe the light blue VMs live in the light blue data store because that's where there's a light blue policy. Remember, every virtual machine is made up of at least 2 and maybe 4 vVols, right? You with me so far? So in the old days, we may have 10 data stores or 100 data stores to manage as a storage team, as a virtualization team. With vVols, this might be what all of those data stores live. Remember, these are all volumes, individual volumes that, traditionally we managed as LUN objects. This is terrifying. This is herding kittens on steroids. This is the corral of puppies that were in the expo, but like 4 acres in size with that much more dogs. Luckily, SPVM is what ties all these things together and makes them approachable. Because if you have a policy engine and you're tagging your policy to your VMs, it manages all of this chaos. So here's how you fail with vVols. I'll talk about failure and then we'll talk a little bit about success. Same basic talk, but we're going to talk about it in 2 different ways. If you don't consider how you're doing backups, how you're taking snapshots, how you're doing backups, what software you're using for backups, and you implement vVols, you're probably going to fail. You want to know how your Veeam, your Commvault, whatever rubric or Cohesity or something like that, how it deals with vVols, what their capabilities are. You have to consider or reconsider your operational processes because things change, right? The way you provision storage in ye old days is very different from how we do it with vVols because it's largely deployed by the person or the script or the automation that's deploying the virtual machine workload itself. If you don't take into consideration your roles and the privileges of users in vCenter, you really should, because vVols changes who has the ability to create storage objects and consume storage capacity. So you have to think about what is the impact of shifting the responsibility for making smart decisions about how big to make disks, where to apply a policy. If you don't take into consideration analytics, dashboarding, reporting, scoreboarding, metering, this is a pattern of failure too, because we don't look at a data store, a vVols data store and look at capacity. We get our capacity or performance information at the vDisk or the volume group level. And we're not looking at data store, the macro data store for virtual machine performance if we can actually look all the way down at the virtual machine level or virtual disk level. Does that make sense? A lot of times we like to, our major monolithic data store with 1,000 VDI desktops in it, we want to look at performance there. We actually can go a lot finer, look at a finer grain of sand, and we have to kind of change our tooling and our methods sometimes. If you don't discuss the value of vVols with your stakeholders, the policy orchestration, the consistency of data services, the ability to take instant snapshots as part of your backup, part of your lifecycle process, the ability to attach any one of those virtual volume instantly to another VM, really attractive for developers that want to take maybe dev code and attach it to a production server instance. You're kind of missing out on kind of selling this technology to your teams. And if you don't consider the best practices, the vSphere best practices, your storage vendors' best practices, failure scenarios, what can go wrong with vVols? Because things can and do go wrong sometimes. So how to win? Don't go full throttle out the gate. Test with a small sample size, get used to vVols in the lab, do the hands-on lab. Did anybody do the hands-on lab this week? Do that hands-on lab a couple of times, or maybe get a lab set up in your home office or your place of business and practice a little bit. Get used to SPVM policy management. Get used to doing PowerShell or REST API-driven management of those vVols, perhaps. Don't sit down at the console and start building crazy, complicated SPVM policies at the console. Go to a coffee shop or a bar, get a napkin, bring a friend, and sit there and map out, what would a gold policy do for us? What could a gold policy? And map that out before you actually try to commit it to code. Consider those user personas in vSphere. Make sure people don't have too many privileges, but make sure they have enough. Use VM service level tags. Actually, about an hour ago, I did a session showing how you could very easily use Power CLI to go after machines with a certain tag, and then assign an SPVM policy corresponding to that tag. Consider choosing a storage platform that has an integration that allows you to build an SPVM policy in the vSphere web client, but at the same time, a storage policy is created on the storage backend. the place I work, we offer that capability. It's great. It means that the storage team doesn't have to build a protection policy, call me and say, hey, we built a policy and we called it silver. And I have to say, it's supposed to be called gold. And then once it's built, then I have to build a separate policy and attach to that storage policy. We do it in one workflow. It's very elegant. And then think about the amazing capabilities of what you could do. The art of the possible is think what you could do with an individual volume that you could snapshot, replicate to Azure and attach to an Azure VM. Really, really cool possibilities once you have that ability. So thank you very much for your time. I'm easy to find on LinkedIn. I've got a blog that I update occasionally. I'm just getting started as a blogger. So late in my career, it's a little weird. But thank you for your time, and I'm looking forward to seeing you at next year's Explore conference. Thanks so much.